For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started. All right, looks like we are live late night on SFT. Good to see some good people. The party's already getting started. Doki Doki, thank you so much. I appreciate the support. God bless you. $10 super sticker and a $4 super sticker. Thank you so much. Good to see everybody. Brother Baptist Chad says, SFT making coffee. Even for me, it's a little late for that, although it is tempting. It is tempting. So I hope everybody is well tonight. Good to see everybody. Luca in the house. Good to see you. I hope you are well. So we're going to be going over a number of topics today. Actually, I'll do a couple brief announcements first, and I'm going to screen share here because we've got some articles up I want to make you guys aware of if you're not already aware of the articles we're putting out. Brother Montaz, good to see you. Good to see you, brother. So, yeah, let me see here. We're going to screen share, go over a few things first. All righty. George Bond, we missed you. Hope you had a good vacation, brother. He says, I'm drinking coffee out of my devolution cup. That cup makes the coffee taste even better. I'm actually wearing the devolution shirt, George. All right, let's have a look here. Okay, so here's our creationist clothing website. Let me know how the audio is, guys. I've got quite a bit of programs open right now. Matt and I, Team SFT, all of us, we're working overtime for you guys. We've got a lot of interviews and discussions planned for you leading up to Christmas. And then we want to plan some good stuff for you in the new year. Have a lot of our favorite young earth creationists back on with us to discuss these important topics. And we're going overtime, doing our best to release a couple books. One I've been working on for a while, Special Creation, and another one that Brother Matt is working on that we're hopefully going to get both of them released by Christmas, at least for the new year. That one's titled Taking Back the Classroom, Curriculums in Crisis. So that's going to be a lot of fun. So that'll add to the information for you, brothers and sisters, friends and family. So here is our webpage. I'm going to check the chat real quick, though, from my phone, make sure that audio is good. And for this week, we should be having Steph on. We're going to be having another lecture from him. And, okay, everybody says it's good. Montaz says his SFT shirt will be on every time SFT is live. I love it, brother. I love it. Okay, so when you go to our website, creationistclothing.com, click the articles section. We just released a couple articles here. Neanderthals and Independent Origins, Refuting the Critics. So the last few debates that I've had on Neanderthals, if you have not yet seen my most recent one with David, we touch on a lot of good issues, a lot of good topics. Genetic entropy, Neanderthals, Neanderthal phylogenetics, for example. So they say that Neanderthal phylogenetics cannot be explained based on the biblical creation model. So definitely check those debates to see that, no, there is an answer, and it's actually the problems with their model that they can't seem to answer. So, but this one is an article I put together that breaks it down in incredible detail for you guys, with some good citations here, going over the Neanderthals in every way, shape, and form, going over their phylogenetics, patriarchal drive. So definitely check that out, pass that around. Tons of good information. This is actually a sneak preview into the book that we should have out by Christmas, titled Special Creation, where I will continue debunking the critics and giving overwhelming evidence for independent origins and Adam and Eve. So this is actually featured in special creation, upcoming book. So the other article we put out, guys, is Jamie, brother Jamie. Good to see you, my man. Good to see you. So I know we're streaming kind of late tonight, but John Maddox had one of his always memorable open mic nights. So I wanted to make sure we were not conflicting in stream. So this is late night with SFT as usual. This boy draws. Good to see you. Good to see you. Actually, now that things are clearing up, we can set up a discussion or debate soon. This boy, I think that'll be fun. So here's our other article we just released today. Human Origins, Dismantling the Critics. So definitely check this out, pass this around. All the typical arguments about alleles, genetic diversity, origin of the skin colors, you know, the races that they say that we can't explain. There's only one race, the human race. Arguments to Dr. Jensen as well, we address here with some solid resources and citations. So definitely check that out, guys. And our new created heterozygosity shirt, we got to send one to RJ Downard right away. I'm sure he's still waking up having created heterozygosity nightmares. So for the actual shirts, our brother did a great job on this shirt as well. Right here, created heterozygosity. So those are just some brief announcements. Good to see we got some people. Jamie, thank you so much. I appreciate it. You're quick, Jamie. You read through it quick. Jamie's always got great things to say, great comments. We were just talking about the Bob Enyard and Brian Nickel discussion we had just last week. That was awesome. I mean, heat problem destroyed. Prediction after prediction that the evolutionists are not going to be able to address. Baptist Chad says Evo is a fax because he says so. Yes, Chad, you and a banana plant are related. Regardless of the empirical data, you're related to a banana plant because I said so. Because the science textbooks say so. Okay, guys, so we're going to be addressing a few things today, okay? This will probably be broken up into a couple parts because there's kind of a lot I want to touch on. We're going to start with just some basics on mitochondrial Eve, Y chromosome Noah, kind of going over a few reasons why the critics are still misrepresenting and straw manning the model and the data and still have not really addressed the data and the evidence, nor have provided any predictions of their own. Doki Doki, thank you so much for the super sticker. Got a couple clips, couple videos we're going to play too. I also want to discuss endogenous retroviruses a bit and end it with some genetic entropy. Genetic entropy is always fun. I want to hammer away at some common arguments I still keep hearing. And it's always a blast debunking the critics on genetic entropy. Okay, so why don't we start with, I'm just going to screen share here just to give you an idea. Actually, you guys might have questions. So I just wanted to point out the fact, and I want to break it down for the audience, okay? And at least so you can see a phylogenetic tree. You know what I'll do? I'll share screen here, and we'll discuss this a bit. We've also got Y chromosome right here. So here's what's amazing is they never want to address the bigger picture. The fact that whether you're looking at a Y chromosome family tree or a mitochondrial DNA family tree, the number of mutations, you're only looking at a few hundred generations max. The evolutionists cannot explain why there are such few mutations, such low variation, that all point to not just two common ancestors in the distant past, but two recent common ancestors. So if there is any questions, guys, I'll pull up the chat on my phone. Good to see everybody here. Doki Doki, hey to you too. So here's the thing. we always point out that we like the uniparentally inherited DNA compartments, okay? Which would be, as you can see here, the Y chromosome and the mitochondrial DNA, okay? Where you can build some very telling family trees, very interesting family trees. And we know Eve, guys, if you have not yet read this paper, the Eve mitochondrial consensus sequence, we have her sequence. We know her. It's not difficult. And the number of pedigree studies that all confirm a young date. And remember, your critics like Dan, your critics like Evograd, Mays, Dr. Frello, okay? Regardless of, say, the error bars or the dates you may derive from the various numbers of pedigrees, it's nowhere near the date that they need. But they miss one thing. They miss a huge aspect of our model, which is the population bottlenecks, according to our model, which would lead for a time to incredibly fast substitution rates and mutation fixation, okay? Which actually perfectly explains the data that we get from the large number of pedigree studies where you can get dates from, say, 6,000 years up to 30,000 years. Okay. Even your higher dates is exactly what we'd expect based on the model, based on those periods of time where we would have incredibly fast substitution rates, for example, where mutations are being fixated. Fixated just means to be stuck into place. Okay. And if you guys have not yet seen it, watch Brother Ramad's video demolishing Dr. Dan's points on Dr. Jensen and his predictions and his model. Watch that, which you can find on Sal's channel. Okay, so let's see. George Bond, thank you so much. I appreciate it. Doki made me do it. Montaz, good question, says, out of curiosity, when did you accept Christ, brother? Well, I grew up a Catholic, so but I did not accept the gospel. I didn't believe on Jesus Christ until about 6 years ago. 6 years ago now. So great question. So I've been at this for about 5 or 6 years. Lucas says, you can show in detail those unrooted trees. I really want to see the center of those. Modern Day Debate says, you live at 3 a.m. Yes. MDD, brother. We are party animals here. Okay, so let's see. Awesome. Jamie Russell, I appreciate it. I appreciate it. Yes, MDD, the party doesn't stop. We don't sleep around here. We drink coffee all day, every day. Because you know what? When you got evolutionists around, there ain't no time to sleep. Okay, so let's answer over a couple things with Luca and his question here, okay? So I want to point out that this tree here and the mitochondrial DNA tree, unrooted trees, okay? This one is on the Y chromosome. Dr. Carter points out an unrooted neighbor joining phylogenetic tree of the Y chromosomes, okay? Based on the Simon's Genome Diversity Project data. You can read this paper, must-read paper. I referenced it in Walker and I's debate on Modern Day Debate in detail. So this attempted to sample from a wide range of peoples. The result is a tree that is a good representation, guys. So this is a very solid representation of total worldwide Y chromosome diversity. Now, here's the thing. Okay, phylogenetic tree programs, they give you the opportunity to have a rooted tree or an unrooted tree. Now I'm going to keep going. Note the clear central starburst, right? So you see the starburst pattern, okay? Explosive growth from a starting point, just as our model would suggest. And the irregular branches that display more mutations than close kin. Now, here's why the unrooted tree is important, especially to avoid evolutionary assumptions and evolutionary bias, okay? In this unrooted tree, branches are allowed to spread out naturally, right? We want a natural pattern, guys. We don't need the evolutionary assumptions because when we add in evolutionary assumptions, It actually destroys the evolutionary assumptions based on the human-chimp split and the molecular clock, which we can touch on a bit later. The evolutionary root would be located midway along the A1 branch. Forcing a root, okay, so this is what it would look like. Forcing a root at that point would produce the squared off stair-step tree, okay? So that is what's more familiar with evolutionists and what they're reading. Let me check the chat real quick. Okay, good, awesome. Hey, even at 4 a.m., we got a bunch of people. This is good. Okay, so let's see. Forcing a root at the evolutionary point would produce the squared off stair-step tree, perhaps more familiar to the majority of readers, with long spidery branches leading to a few rare African lineages. But this unrooted representation allows for a more natural reading of the data, okay, guys? It also doesn't change the fact, regardless of the data itself, as in the number of mutations that the evolutionists can't explain. Even when you consider genetic drift, substitution rates, and allow for a ton of purifying selection, the evolutionists still can't explain why there are so few mutations, okay, and so far away from the date where they want their evolutionary story to be when it comes to human origins and their out of Africa theory, okay? So we want the unrooted tree. We like this representation because it allows for a more natural reading of the data that can then lead to predictions, right? Dr. Jensen, we've covered it over and over again, the number of predictions that he's gone over. Let me know how sound is and everything, guys. Okay. So anyways, let's get back to what I was saying. You can read about this in the paper here in 2018 or on Patriarchal Drive, where they talk about this in great detail. And this is empirical evidence, guys. Okay. So I want to make this simple for everybody. Just so when we're talking about these technical issues, technical topics that we're constantly debating, I want you guys to understand exactly what we're discussing. So why we like the uniparentally inherited DNA, right? This is a mitochondrial DNA tree. We were looking at the Y chromosome one earlier. For one, okay, this is a major reason why we love it. It's because the mitochondrial DNA, okay, it's passed down from mother to child, but it also lacks recombination. It's not as messy. Okay, it's not as messy as the nuclear genome. We can also agree with the evolutionists that, hey, the DNA differences we see in these uniparentally inherited DNA compartments, they're the result of mutations. We can do a head-to-head prediction with the evolutionist. The Y chromosome, same thing, guys. Passed down from father to son. And that's why, as you can see here, and we've touched on briefly, we can build some very interesting trees from the mitochondrial DNA and the Y chromosome. And as you can see here, mitochondrial trees and Y chromosome trees grow in branching like patterns, right? We'll go back up to the Y chromosome tree. Okay. One day we'll really go into detail on what all this means and the different branches and the different points here. But for now, I just want you to take away from this the fact that these trees, whether we're looking at the Y chromosome, the mitochondrial DNA, they grow in branching like patterns, okay? And why this is, though, guys, it's due to mutations, okay? So for the audience, like I said, I want to make this as understandable as possible. What we can do then is we can literally reverse the clock back to the point where we would find Eve, or say our last Y chromosomal ancestor. And if we wanted to, okay, let's focus on mitochondrial DNA right now. If we wanted to, we could start with Eve being the mother of us all, okay, the mother of all living, as the Bible tells us. She would have children, and then her children would have children, okay? And every time a child is born, what may happen? Well, there is that chance that the child would have a mutation. Now, mutation is essentially a copying error, okay? It's not going to help large-scale evolution. We're going to talk about that a little later with genetic entropy. But every time a mutation happens, what happens is we are going to get a new branch on the family tree, okay? And over time, the family tree gains more and more branches, right? Just as we see here, due to mutations, due to these copying errors. Now, what we can do is we can actually take this back. We can back this process up, guys. It's like a clock, okay, that ticks every single generation. We can back this up to the point where we eventually find the woman of whom we have all descended from, as the Bible tells us is Eve. But here's the thing, as we were discussing earlier, and I really want to emphasize this. There are only about 20 to 30 mutations. Guys, there's only about 20 to 30 mutations that separate most people in the world today from our Eve ancestor. The most you're going to find is about 100 in the most diverse people groups on the planet, okay? Not a lot at all. The evolutionists can't explain it. You should see the stories they got to come up with, okay? This is why they want to look to the phylogenetic rate. This is why they don't care about the pedigree rate. Wave it away. Dan was saying, more or less, he doesn't have a problem with the Parsons paper, the Parsons rate. Probably because Rahmat and I showed Parsons' response to the critics. Parsons said if he did it again today, he'd come up with the same data, the young date of 6,000 years. Okay. So that's important to consider. But guys, if the Bible account of human origins is true, and we have all descended from Eve just 6,000 years ago, it's so easy to account for all the mutations we see today. This is the bigger picture, guys. That's it. This is very easy to account for in the biblical model, the biblical time frame. As a matter of fact, the pattern, okay, you start from a center point. You see this starburst pattern. Our model says rapid population growth from a starting point. Okay, we have a starting point at creation, a starting point at the flood. We also have a starting point, in a sense, at the Tower of Babel. Okay, events where we're looking at incredibly fast substitution rates. So even when you see those ranges in your pedigree studies, okay, remember, mutation rates are still way, way too fast for the evolutionists, way faster than the phylogenetic rate. But here's the thing: when you consider all the studies, we don't disagree with all the studies. The critics, Dan was saying, Rahmat and SFT, they disregard all the studies. We have a book out, Mutation Rates, okay, the truth about mutation rates, where we go through every single study and we point out the problems in some, we point out the pros in others, pros and cons of all the studies. But here's the thing: regardless of whether you're looking at a study that comes up with a 6,000 year date or a 30,000 year date, this is considered young. But we would never expect an exact date of, say, creation, okay? Because there's certain things in our models, like the bottleneck events, where, as I've said, you're going to have much faster rates of fixation, okay? There's still very few substitutions overall, all easily explainable by our model, accounting for everything that people like Dr. Dan want to say we don't account for, okay? Bottlenecks, genetic drift, substitution rates, purifying selection. No, this has all been accounted for. But here's the thing: the evolutionists are not going to tap out, guys, and they're also not going to give predictions of their own. So it's extremely easy to account for what we see. And this is why the critics have an incredibly, actually, in my opinion, an impossible time explaining why there are so few mutations separating anybody on this planet from the mitochondrial Eve consensus sequence and the Y chromosome Noah consensus sequence. Okay, let me check the chat since we're on screen share. George Bond, $5 super chat. Thank you so much, brother. I appreciate it. I hope that coffee's tasting good. He says, now here's the thing: the only facts of evolution are the missing facts. There's a lot of missing facts. You are right, brother. Doki Doki Bible Club. Thank you so much. That's the book right there. The True Story of Mutation Rates. Guys, we go through every single study. We've also had hours and hours and hours and hours of streams. I don't think anybody has gone through the studies in as much detail as we have. They've just all been ignored by the critics. That's not our problem. That's not our fault. Okay? And I'm not going to go through every single study again right now, as we have done, and make this stream another 10 hours. It's up to the critics to go watch those. God bless, Chad. Thanks for being here, even late at night. Awesome. Awesome. Great comments, great input. Now, here's the thing. CRISPR, Dan, these critics, they are right about, so for example, Dan, in his stream with Sal, his explanation for pedigrees, which we would say is the empirical rate, the empirical method, was correct. Using the empirical method, guys, we can compare mutation rates in the present. That's why we like it so much. And in pedigrees, all we're doing, okay, for anybody who's not familiar with what a pedigree may be, we're using parents to offspring, okay? And when comparing the mutation rates, I should say, between parents and children, it turns out, to the surprise of the evolutionists, that the mutation rate is much faster than the phylogenetic rate, which is based on a lot of assumptions, as we've touched on. And they don't like these fast mutation rates. It conflicts with their deep time evolutionary story. And that's why people like Dan would just say, I don't care about the pedigree rate. I more or less don't mind, or I don't have any problem with the Parsons rate, because they want to focus on the phylogenetic rate as compared to the pedigree rate. But as I've pointed out, it's hilarious, and I've said it over and over again, they got nothing yet, because even when we consider the substitution rate, even when we allow for a massive amount of purifying selection, which we've done, we still find far too few mutations for the evolutionists to explain. This is the bigger picture, guys. Okay? Now, here's the thing. What CRISPR was saying to Erica in their 3.5-hour rebuttal video, I don't have a problem with, because it's true. By definition, guys, the pedigree rate is obviously slower. Okay, nobody disagrees with this. The pedigree rate is obviously slower than the actual mutation rate, simply because a lot of these mutations will get weeded out over time. This is just basic. But these critics, what they do is they straw man and they misrepresent. Because the fact is, young Earth creation scientists like Jeanson, Sanford, Carter, they know this. They've accounted for it, which is why they are so willing to make testable predictions and accurate retrodictions, guys. So I hope that kind of breaks it down a little easier for you guys, to make it more simple, to see what we're looking at, what we're arguing about, why this is important, and why the evolutionary model fails, and also why these unrooted trees here gives us the patterns that we would expect. It allows for a more natural reading, okay? And when we add in the evolutionary assumptions, it doesn't work because of the breaking down of that molecular clock assumption. Baptist Chad, brother. Thank you for the support for my coffee addiction. I appreciate it. I appreciate it. All righty. Yes. Dr. Rob Stadler, please. Doki Doki is so right. Please go check out our interviews with him, especially the last one on his book. I did a series as well based on his book, Low Quality Science. Okay. And I got to point out that Gutsa Gibbon did a couple videos on just that, promoting the low quality science, like the fossil record, where we don't really have the genetics. We don't have the direct lines of evidence. The fossil record, which is low quality, low confidence science. A lot of assumptions. You can go to the fossil record and pretty much invent any story you want. That's why the genetic data, the direct lines of evidence, this is the best way to answer this question of ancestry, okay? And it's, as you can see, it's being answered beautifully well. Beautifully well. So as you can, I hope that helps with what this visual representation is, what it's based on. Okay? What the lines indicate, the pattern, what a pedigree rate is versus, say, a phylogenetic rate. Okay? Now, this here, I've explained many times. Walker and I discussed it in our debate. Okay? And you see all types of people groups in here. African specific groups, Europeans, Asians, for example. Okay? And I find it fascinating that what we see here, that starburst pattern, explosive growth from a center point, okay? All this data did not have to come back to be true. And you know what? For the 1000th time, okay, which the critics don't seem to get, let's look at this, HVR. You're going to notice how the branches all have different lengths. Notice this, okay, if you can see my mouse. What this means, guys, is the people in here all have a common ancestor, but yet one group in there, it turns out that they've picked up twice as many mutations as their cousin. Okay? So here's the thing I want you guys to consider. If it is possible to pick up more mutations in the same amount of time, then we obviously can't look between, say, humans and chimps. The evolutionists say humans and chimps split from a common ancestor roughly 6 million years ago. Chimps are our closest cousin, according to the Pond Scum to People evolutionary fairy tale, okay? We can't look between them and then make an assumption about when they split, okay? Because remember, this is just random mutations occurring in populations over periods of time. The bigger picture, which they want to ignore and is never addressed, guys, the bigger picture, okay? We see a pattern. The pattern goes back to what? A center point. And this is a beautiful natural reading of the data. Okay? We don't want to root it because of the assumptions. The molecular clock. We can't assume the split. We want a natural reading and we want to make predictions, which have been done. You've got your Ian Chen spamming the comment section saying Jensen's not making predictions when we've gone over a huge number. I literally addressed him live. Told him to come in. He didn't, which is fine. But I must have went for 15 minutes explaining the history of civilization, the predictions being made in regards to genetic stamps in the Y chromosome, mitochondrial DNA. Maybe it went over his head. I don't know. But he spams the comment sections with the same arguments that have been answered. And it's funny. We love them. We love them. But that's the bigger picture, guys. Mitochondrial DNA and Y chromosome. Let's go back to the Y chromosome family tree. They mutate faster than evolutionists ever expected or predicted. Creationists are making predictions. Evolutionists aren't. Dan attempted. I give him credit. He attempted, and Matt and I decimated that claim in a 2-hour video addressing that prediction in great detail. Okay, we see one woman, one male, exactly as what the Bible says and has predicted. Mitochondrial DNA and Y chromosome DNA. Very little variation worldwide. Humans have low genetic diversity, exactly as what was predicted and expected based on the Bible. They can't explain this other than with rescue device after rescue device after rescue device. Post hoc, ad hoc population bottlenecks with the out of Africa population bottleneck. No predictions. Guys, look at this. It's clearly a reflection, okay, based on everything we've talked about mutations and the branches, okay, the branching like patterns, how fast the rates are, okay. This is the Y chromosome phylogeny. Go back to the mitochondrial DNA one. This is clearly only a reflection of thousands of years, okay, and not the deep time, let's say hundreds of thousands of years, as the apologists of human evolution want to say. There's not a lot of mutations on both the Y chromosome family tree and the mitochondrial DNA tree. And guess what? when we don't use evolutionary-based assumptions, there's only one obvious conclusion to this data. The tree's young. Okay, we've descended from a single female ancestor and overall a single Y chromosomal ancestor. Both nothing like the chimpanzee. Okay, so I want to make that clear. All right, a shot of coffee would be good, this boy. So any objections or anything, let me know. Let me know in the chat. Montaz, I appreciate it, brother. I want to make it good fruit, my man. If there's any questions or if there's ever any if there's any advice or any opinions on how to make the streams better, let me know. Baptist Chad. Yeah, I don't think she'll debate genetic entropy because it's pretty much the critics want to wave it away, and they've even admitted it. That's why we've got a Jungle Jargon. Good to see you. So yeah, objections, questions, let me know. Let me know. It's pretty. I mean, it's pretty clear cut. You know, there's no way around it. Doki, thanks for the wink. I appreciate it. I appreciate it. So, you know, this is just fascinating because all of this did not have to be true, and yet it is true. So anybody who just got here, check our article section. I'm gonna have a drink of water here. We just released a couple new articles on Neanderthals. Doki Doki Bible Club. You know what? I really want to show you. So Dr. Carter, I've got the video pulled up. We haven't shown this one in a while, but he did a really good job explaining what I just said, but also showing the fact that this was not expected under their model. Not even close. Okay, because they want to invoke, as we know, coalescence, and they want to say that this is exactly what we would have predicted, exactly what, you know, the evolutionary model or story would have expected, which is very far from the truth, guys. So I'm going to play this clip right now, just a short one, and then we're going to get into endogenous retroviruses. Doki Doki, thank you so much. I appreciate it. 8:30 p.m. in Sydney. Perfect time for Ian Ask Questions Live. Yes, Ian. Yeah, Ian. Live questions would be a lot better than the comments in the comment sections after the fact. Thank you so much for the super stickers, super chats. You guys are awesome. Lots to look forward to for the new year, I promise you. So let's share screen here. I'm going to mute myself, guys, so there's no echo. And give me 1 second here. We'll be good to go.
Creation model, which makes no sense. No, in creation, God can front load the genome with as much diversity as he wants to. If all variation is caused by mutation, absolutely, it's impossible. You can't get all the variation we see in modern people if we start from Adam and Eve if they're 100% homozygous.
Right.
But what if God front loaded Adam and Eve with like 20 million variants? Then we can lose half of them and still have as much as we have today. And 20 million is not a lot. I carry 3 or 4 million. You carry 3 or 4 million of the common ones, and probably 3 or 4 million rare ones. That's fine. So it's actually trivial to start with Adam and Eve and get the people we have today as far as the number of variants. Especially if you had 6,000 years of mutation, you can have a lot of new variants appearing in that 6,000 years.
Right. They're coming from their perspective of the evolution having to work in a short time period.
Yeah.
Well, so what are some of the best evidences for a literal Eve and a literal Adam?
Well, the best evidences are the fact that we found Y chromosome Adam and mitochondrial Eve. Now, the evolutionists put them in a different place where I would put them, but it's quite clear there's only one human Y chromosome. And all men share a very similar Y chromosome. That didn't have to be true, because if we came from a common ancestral population with chimpanzees, that ancestral population would have had a diversity of Y chromosomes. And when the population split into the lineages that led to humans and chimps, it's possible that we could have, like, in this ancestral population, type A, B, C, and D. Well, if humans have type A and B, and chimpanzees have type B and C, that means there would be a human and chimp who both had type B. They're more closely related to each other than a human is to another human. on the Y chromosome. But it didn't work out that way. It's mathematically and theoretically possible, but it's totally not true. There's only one Y chromosome. In fact, just yesterday, or maybe the day before, they redid the Neanderthal Y chromosome, which is really weird to me because for a long time we only had female ancient DNA. All the Neanderthals, all the Denisovans, as they're sequencing, they're all female. Like, why is no males? We got like 20 females and no males. Something really weird. But they finally published a partial Neanderthal Y chromosome several years ago, and it was way different. I mean, way out in left field. Like, oh wow, that thing's really different. Well, just a couple days ago, they replaced it with a very modern human one.
Wow.
And the Y chromosome common ancestor between Neanderthals and humans, modern humans, is much more recent than it was last week. They totally redated it.
Incredible. Wow. Where can we find that study? I want that one. But so how about molecular clocks then? Do they support a literal Adam and Eve? And is there a constant clock? Is there an average clock that can actually be made?
Yes and no.
Okay.
If you take a constant average for things we can measure in the laboratory today, you can get an approximation of how long ago Y chromosome Adam or mitochondrial Eve lived. It's only a few thousand years. You don't need tens or even hundreds of thousands of years. Now, they don't like doing that, so they're like, the Y chromosome right now, the clock is grounded in the time when Native Americans got to North America. In fact, the Y chromosome guys, they call that a sanity check that appears in several papers. So they're not using genetics, they're using archaeology to give them a clock so they can figure out how far long ago mitochondrial Adam was, Y chromosome Adam was.
Oh, yeah.
Wow, that's interesting. But if you look at the measurable mutation rate from one generation to the next, it's a lot faster than they want it to be. But I don't like the molecular clock idea. I don't think it works. If you look at a Y chromosome family tree and you look at people that are closely related, maybe in the same group, well, some of those people could have twice as many mutations as their cousin or relative that came from the same founder of that group.
Mm.
So like group R1b, I'm an R1b, 80% of Western Europeans are R1b. If you look at the R1b founder and then you measure the branch lengths of all the individuals that are R1b, there are people twice as many mutations as, wait a minute, that means there's no clock. That means you can't put your finger on the tree and know how long it took for these many mutations to accumulate. And yet, if you just do a rough approximation, everything is young. There's another issue. I wrote an article called Patriarchal Drive. I published it in the Journal of Creation, did some computer modeling. I said, we kind of know that the older a father is, the more mutations he passes on to his children. And I said, but if Noah was over 500 years old when he had Shem, Ham, and Japheth, and that population was reduced to 6 people, that means those 3 sons, their father was over 500 years old when they were born. That means they each got a huge dose of mutations. And as that post-flood population starts growing, these really old men are going to continue to have children. And the older they get, the more mutations their children are going to have. I call it the patriarchal drive. And what it does is it totally messes up the average. It takes, some kids are being born in this population with 800 mutations, and some kids are being born to a young father and they only have 10 mutations. So you can't look at the branch length on the tree and know that the branch length equals time. It does settle down after a while when now, men today aren't having children when we're 500-600 years old. We tend to have children when we're 30 years old. That's a huge difference.
Yeah.
So there are problems with molecular clock, archaeologically, genetically, philosophically, mathematically. Yeah, we can still use it if we want to.
Okay.
So, question from, thank you for the super sticker. I appreciate it. Stevie, good question, brother. Will SFT respond to IP's video against young Earth creation? Definitely. So we're going to get together, do a full response. We could refute it in our sleep. IP never addresses the scientific data, the predictions coming from young Earth creationists, and his hermeneutics are horrible. So we're going to address that. We did have a massive comment that we put together. Raw Matt put it together, addressing each point. It was on his original video, but then he removed it and re-uploaded it. I think he found a mistake. And we've also debunked some of his points on like to subdue and have dominion and in previous videos. So yeah, we're going to do a full video on it for sure. And I'm excited to do so. So Nicholas says, Nicholas, probably same thing, brother. Nicholas probably watches that video and he can just refute it point by point. So, IP, I don't know who he thinks he's making these videos for, but any informed young Earth creationist will just tear it apart. And here's the thing, inspiring philosophy, he's only parroting arguments from John Walton, Michael Heiser. And all those arguments have been destroyed in detail in highly technical articles, right? And that's who he's getting those arguments from. So they've already been destroyed. So it's going to be an easy video to debunk, and we're excited to do so. Now, the video we just showed with Dr. Carter going over a few important things when it comes to molecular clocks and Y chromosome, mitochondrial DNA, patriarchal drive. It hasn't been addressed by the critics. It hasn't been debunked. Patriarchal drive is very interesting because, as Dr. Carter was explaining, we know Noah was extremely old, and therefore he would have passed on an incredible amount of mutations to who? Shem, Ham, and Japheth. And they're the ones, them and their wives, they went on to reproduce the world. Okay? And after the flood, you would have had these small populations. And for a time, okay, until longevity really decreased to pretty much where we see it today, these biblical patriarchs, they would have been having kids in their old ages, and their kids would have been having kids. And there would have been a huge amount of mutations per generation. So definitely check out the article we just put out that I wrote on Neanderthals, because I spent a great deal of time on patriarchal drive, and I think you guys will find it really interesting, and it's a lot of fun. So anyways, I wanted to now go into endogenous retroviruses, because these points have been brought up lately on viruses in general, guys. And I put out a video today that I'll play for anybody who hasn't seen it. But there's been some critics, one specific critic on my SFT Facebook page, who I said, instead of the comment war, let's have a live debate. He doesn't want to do it. The name he goes by, at least on Facebook, is Barry. And he's written blogs and blogs and blogs on ERVs. And I'm happy to debate him on it live, okay? And he was having a back and forth with one of the brothers, Redefined Living. And he was saying, how do you explain that the Phoenix experiment, there's an experiment, okay, that he's looking to, supposedly resurrected fully replication competent retroviruses. Okay, his blog, that specific article is titled "The Phoenix Virus: An Explanation of an Experiment." But it's so funny, and this is why I want to get this guy in a live debate. Okay, this is why I want to get him in a live debate, because this is where you can call them out for tap dancing. This is where you can call them out for dodging and also misrepresenting. I've pointed out in my numerous debates with popular YouTubers too, like Conspiracy Cats, Team Skeptic. Okay. I've debated biologists on this. One biologist I debated on T-Jump's channel. We spent 30 minutes on ERVs. And I said, the question is, okay, guys, and remember this. And also let me know how my audio is too, because I'm trying something new. So the question is this: are these endogenous retroviruses, okay, these various classes of retrotransposons, are they really the ancient remnants of viral infections, okay, that have been passed down? Or are they created units of DNA function? If they really are created units of DNA function, what would we predict? Well, function, of course. Okay. So this critic, Barry, okay, his blog is named barryhisblog.blogspot.com. Okay. All easily debunked. Actually, he bought my book. Thanks for the support. He left a review, and mainly just focused on endogenous retroviruses and ignored everything else confirming independent origins, which is fine. But he completely misunderstands this point and this question that I just went over right now, okay? Because the question is not whether endogenous retroviral-like sequences can actually form viruses, because I've discussed, and I've even discussed in my books, that there is a creationist hypothesis. I look to these elements as variation-inducing genetic elements. They're beneficial. They were created to be helpful and beneficial and functional. Again, I recommend my debate with Conspiracy Cats, where the whole debate was pretty much ERVs almost. Okay? So the origin, according to at least one of our hypotheses, the origin of these viruses, okay, post-fall, is that they arose from endogenous retroviral-like sequences in our genome, instead of viruses coming into our genome from the outside. Are they coming from the inside? Are they created? Or are they coming from the outside? And this was this Barry guy's best argument. And I say, come debate me live. Okay, he wants to take me away from that which is important into an endless Facebook comment war. Okay? So that's the question, from inside or from outside? The evidence seems to suggest that our genome is the source of viruses to begin with. So here, I'm going to ask it again. This is what the question should be. So this Phoenix experiment doesn't help differentiate between the models. The question is whether our ERV-like sequences are functional. And that Phoenix virus experiment doesn't even begin to address that question. Okay? Here's the thing. And here's what's important. And one debate that comes to mind was with Mark Drysdale, where he was all hung up on viruses. Why would God make viruses, especially viruses that are bad? And that's how we started off the discussion. And I pointed out the fact that the majority, guys, okay, you need to put away what you thought was true and use your critical thinking skills. Most viruses are actually beneficial and helpful to our bodies. And people want to say, but don't most viruses cause disease and illness? And I always point out the fact that no, viruses do not mostly cause disease. Okay? Here's the fact. There are actually more viruses, okay, than there are bacteria. For example, if you were swimming in the ocean, what that actually means is you are swimming with an ocean full of bacteria. And what's funny is there are more viruses than bacteria. So what are the viruses doing? Well, they are controlling and regulating the amount of bacteria. It's ecosystem balance. This is important. You would not want to live on a world without viruses or without bacteria. Now you've heard, okay, that we also have more bacteria in and on our bodies than we do with cells. And we have trillions and trillions of cells. And yet we have even more viruses than bacteria. So why are we not all dying within an hour if viruses are bad? No, they're beneficial, they're helpful, they were created for purpose, for benefits. They're doing the same thing that they're doing in the ecosystem of, say, the ocean. They're controlling, they are regulating. It's all about control and regulation of the number of bacteria in our gut. I take probiotics. A lot of people take probiotics. Good bacteria, that's good for you. Especially when you just got done a round of antibiotics where it's killing all your good and all your bad bacteria. You should take then a round of probiotics. See how the chat's doing here. And okay, good questions, good comments. One question from Luca. And JJ says, I always said ERVs are rogue information. Yeah, so Luca, once again, that's not the point. Is we know how to recognize viruses. We know how to recognize viral-like elements. Just like this apparent Phoenix experiment, just like the lines of evidence that the evolutionists want to put forth as evidence for endogenous retroviruses, for example, being the result of universal common ancestry completely misses the point. Are they the result of ancient viral infections, or are they created units of DNA function? Okay, those are the important questions. We would predict function and purpose and benefit, okay, to these DNA elements. Now, recognizing them, that's not differentiating, because that's just recognizing what we already agree is there. The question is, did they come from the inside or did they come from the outside? But you might have asked that question actually before I talked about that, so that's fine. Good question. Okay, so remember, we have more viruses in our bodies than we do bacteria and cells. It's about regulation. The viruses are regulating the massive, massive numbers of bacteria in our bodies, in the ecosystems. Guys, without bacteria, for example, let's focus on bacteria. Without bacteria in the oceans, well, without bacteria in our bodies, we wouldn't exist. You wouldn't want to live in a world without bacteria and viruses. When it comes to the ocean, you wouldn't even want to swim in the water because there would be such incredible imbalance in that ecosystem. Viruses are highly beneficial. Bacteria are highly beneficial. Now, here's the thing. Not all viruses are good, but most of them are. Okay? Now, they can burn hot and fast due to mutation. They can cross species, like with what we're seeing today, with the big pandemic with the virus. Okay? When a virus jumps from its originally created space, okay, or arena, to a brand new environment or field that it can't recognize, that it's not used to, let's say into us as humans, then the immune system doesn't know how to deal with it. It's just jumping from one species to the next. And now that species, whatever it is, it doesn't exactly have the ability to regulate the virus properly. And that's why the virus then tends to burn hot and fast. The best thing that can happen to these viruses is that they mutate to oblivion. Okay? These viruses that look like ancient viral infections, we know what they look like. We know how to detect them. But they're actually very tightly regulated. Okay, guys? And to Luca, they're very tightly regulated into the genomes of living organisms, and they're highly, highly functional. The evidence is clear that they were created this way on purpose. Okay? So not all viruses cause disease. Okay? And I point out the fact that there are certain classes of retrotransposons. Ones that comes to mind is there's one certain class in the mouse embryo that when you deactivate it, okay? The mouse embryo, it's developing, you deactivate, and then it stops because it's dependent on the function of these retrotransposons. Okay? These are not junk. These are not worthless. These are not, based on those two questions, were they created? Are they created units of DNA function? That's what the evidence seems to suggest. And we can have internal and external escapees. The internal escapee can simply be due to a mutation. This is all evidence of genetic entropy. So the next time you hear the word virus, just think of something good, beneficial, and helpful. Okay? Now, when you hear the word disease, yes, think of something bad. But most viruses, most bacteria, they're not causing disease. They're not causing harm. Brother Montaz. Yeah, Lena Powell, great point. That's what's going to happen. It's going to mutate into oblivion. I found it so funny because Doki Doki, that's my mood too. I love it. Jungle says, where did it go? He made a good point. ERVs are rogue elements. Yep. Yeah, good point. Montaz, good point as well, brother. There's no way to refute the fact that viruses are helpful. There's no way to refute the fact that bacteria are helpful. They were created for good, okay? And that's what the evidence seemed to suggest, okay? Because the case is being made, okay, guys? Briefly, I'll touch on it. Now, there's a number of papers on variation-inducing genetic elements from creationists, and I'd highly recommend looking into them, okay? But I'll briefly say that the viruses we see today, they've originated within us. They were created in us, okay? By cellular parts. Cells are packaging things in a variety of ways, okay? And then what happens? Oops. They've accidentally packaged something that is exactly what a virus is. So it's quite possible and logical that viruses came from our genetics, as compared to what most people think of, okay? We have what look like viruses in our genome. And as I pointed out, they're tightly regulated, highly functional. The ones that went bad and rogue, the internal escapees, they're the result of genetic entropy, the result of the fall. Endogenous retroviruses, there's no evidence for co-option. No evidence. I was debating a biologist on T-Jump's channel. I said, show me an example of a non-functional endogenous retrovirus going from non-functional to functional. I've asked all the team dodgeball, never been given an answer, nothing but dodging, because there is no answer. There's no empirical evidence. It's all forced, retrofitted. It's all inferred, just like the orphan genes, okay? No, this co-option is a fairy tale story invented to explain the data. These ERVs, they can act as DNA regulatory elements, long non-coding RNAs. They can act as triggers for the innate immune system. Okay? They're involved in immune responses. Function after function after function. They help accomplish many crucial functions such as gene expression, help in development, and a lot of the activity associated with these transposable elements, they're actually very tightly controlled by epigenetic mechanisms and specific RNA molecules. So it is ridiculous to claim, especially without evidence, nothing but imagination and storytelling. It is ridiculous and unscientific to say that this incredibly complex genetic system came about through ancient invasions of RNA viruses. No. Claiming they were co-opted, okay, it's nothing more than a story to retrofit the data. These ERVs, for example, let's focus just on ERVs, these crucial and critical functions involved in, say, regulating genes. I've got a paper here that says they're even involved in determining cell types. I talk about this with conspiracy cats. I actually have a clip I'll show you, because they'll often say, when I debated Mark Drysdale, no, this isn't true. This is correct, because they're just blindly believe what they were taught to believe. Okay? So when you tell them about how functional these retroviruses are, they dismiss it. And I'm going to show a clip, actually, where I've got a number of papers. Doki Doki, thank you so much. I appreciate the super chat. Good to see everybody. Wow, time flies by when you're having fun, guys. We've been going over an hour. So lots of good comments, good people. Thank you for the super stickers. So I hope this is helpful on endogenous retroviruses. I really wanted to hammer this one. I'm going to show some papers, actually, in 1 second here. Where can I go to find the papers? No, I'll screen share, and then we're also going to show a brief clip. And let's go right here, screen share. Let me know it can be seen. Okay, so let's see. Ton of slides here. So let's go to. Okay, so let's get some papers here. Look at this one. Published August 19th, 2019. This has to do with the retrotransposons. Far from being junk DNA, the pervasive retrotransposons that populate the genome have a powerful capacity to influence genes and chromatin. A new study demonstrates how the transcription of one such element HERVH, can modify the higher order 3D structure of chromatin during early primate development. It's so funny. Where these primates, these mammals, like with the mice, the embryo, then how they stop developing. Apparently they just weren't able to have babies. They weren't able to reproduce successfully and pass on their genes until they got this co-opted retrotransposon or endogenous retrovirus. So you'll find excuses and excuses with this Barry guy in his blogs. All the arguments are retrofitting or inferring or assuming ape to man common ancestry, assuming they were co-opted, not actually answering the question as to whether they really are the ancient remnants of viral infections, in that we've inherited these from a common ancestor, a primate common ancestor, a common ancestor with the chimpanzee, versus are they created units of DNA function? I've already spent 20 minutes, 30 minutes showing how important viruses are. And the same thing goes for viral-like elements too. So no, they can't explain this. It's exactly what, look at all these papers. Retroviral promoters in the human genome. These data suggest that ERVs may regulate human transcription on a large scale. Guys, when God created animal life, the animal types, Adam and Eve, he front-loaded them with a bunch of DNA differences that can lead to variation and adaptation, epigenetic mechanisms, and variation-inducing genetic elements, these viral-like elements, bacteria, okay, other functional DNA elements like ALUs, some of these pseudogenes that were thought to be genetic mistakes inherited from common ancestors. No, God has front-loaded the genomes of living organisms with so many beneficial and helpful DNA elements for adaptive purposes, epigenetic purposes. We have so many millions of genetic switches just waiting to be turned on or off via the environment. Function after function after function. Our genome's multi-dimensional. It's nested, okay? You have messages that can be read both forwards and backwards, okay? The DNA cannot be explained through evolutionary processes. And the forward-thinking mechanisms in the genome that we know exist, they can only be explained by a forward thinker, unless the evolutionist wants to claim that natural selection and mutations and other evolutionary mechanisms have a mind. So let's see, more papers here. Taken together, our findings suggest that HERVs behave like normal cellular genes and are a permanent component of the transcriptome of a cell. Comprehensive analysis of human endogenous retrovirus transcriptional activity in human tissues with a retrovirus-specific microarray. Considering this, right here, endogenous non-retroviral RNA virus elements evidence a novel type of antiviral immunity. Function after function. Regulatory activities of transposable elements, from conflicts to benefits. ALUs influence alternative splicing. Look at this. Scientists identify, it's not just one or two papers, one or two functions. When I was debating Erica for the second debate, it's just one or two. So therefore we can assume that they were co-opted because it's just one or two. And I'm like, it's not one or two. We're looking at genome-wide activity, highly, highly beneficial and functional, these elements. Look at this. Scientists identify new beneficial function of endogenous retroviruses in immune response. Isn't that funny? Endogenous retroviruses play a critical role in the body's immune. Just co-opted, this. No. Listen. Contrary to what the evolutionist says, if it was really the origin of these was ancient viral infections and invasions, okay, well, it would likely disrupt the genome, disrupt the function, as compared to create or lead to a novel function, especially something as critical to the genome as development, cell stress responses, regulation, expression, okay, so on and so forth. So, endogenous retroviruses play a critical role in the body's immune defense against common bacterial and viral pathogens. Isn't that funny? Researchers have found. See how the chat's doing. Ian Chen. Ian, good to see you. We answered some of your arguments earlier. You'll have to go check that out. So Ian will not be able to show us any evidence for the fact that viruses have come from the outside. No. For 30 minutes, Ian just got here, so he didn't see it. We went over the huge amount of irrefutable evidence that viruses, bacteria, they have originated from within. Okay, they are used in the ocean. The viruses and bacteria, they're there for the ecosystem, the benefits of it. You do not want to live in a world without viruses and bacteria, put it that way. Thank you for posting that debate, Doki Doki. And Ian Chen. Ian, so we went over some predictions. Let's see if you can reiterate the history of civilization prediction that I've talked about in great detail. I even called you out on live in our video to Vice Rhino. Let's see if you can reiterate it, because you keep saying there's no predictions. Let's see if you can reiterate the predictions on the thousands of species, predictions in regards to genetic stamps in the history of civilization. So anyways, yeah, so let's see evidence. Let's see evidence that these have all originated from the outside. You ain't gonna find it. You ain't gonna find it. Endogenous retroviruses function as gene expression regulatory elements during mammalian pre-implantation embryo development. I'm gonna show you guys a good article here. Okay. Right here. No, not that one. Right here. So variation-inducing genetic elements. Actually, before I read this one, guys, I'm going to play the quick clip. Just 1 second. All right, so I'm going to make sure the audio is on. Speed in the house. Him Snake, good to see you. Ian Chen, you are famous. You are famous for not being able to reiterate my points that I've made 1,000 times. You're famous. Own it. Rock it, my man. So, and here's what's funny. So Ian Chen, he's totally wrong, but he says, well, Jensen's made no predictions other than the prediction on the Khoisan people, which we don't know yet. Yeah, that's called a future testable prediction, Ian, where you make a prediction that only future observations and experiments can tell us whether it's true or false. That's called a prediction, okay, as compared to a retrodiction. Sometimes it takes years before predictions are actually fulfilled. But here's the thing. Dr. Jensen came out with a huge series and some technical papers confirming predictions on the Y chromosome. Gutsa Gibbon attempted and failed miserably to refute those predictions. I put out video after video showing why it's a misrepresentation, and Joshua Swamidas was probably unintentionally misrepresenting Jensen, or maybe intentionally. I don't know. So here's the thing. Here's the thing. There's been predictions that only future observations can tell us whether or not they're true. And there's been predictions that have actually already been shown to be true. And the evolutionists just aren't up to date on it. So it's just sad. But that's why, Ian, I'm looking forward to getting you into a live debate. Very excited. Very excited. Ian might want to come in right now, actually. You know what? Typically, I don't do that because that might... Ian, come in here, and I want you to reiterate my explanation for Dr. Jensen's predictions on the history of civilization, not only in the Y chromosome, but also in the mitochondrial DNA when it comes to phylogenetics, genetic stamps, and genetic signatures. So let's see if you can reiterate that. Anyways, let's go to this clip. And just, Ian, we love you. You, Luca, speed of sound in the house. We love you all. Even though you guys are dodging, ducking, dipping, diving, dodging, all over the place. It's fine. We still like you. You guys just have to own it. Yeah, I'm just kidding. You don't have to join. But you could always reiterate the prediction in the chat. Okay, so I forgot if I put the audio on. So let's screen share. So guys, we spent the first about half an hour to 45 minutes debunking critics like Dan on mitochondrial DNA Y chromosome. And then we touched on viruses, the benefits of viruses, bacteria, retrotransposons, ERVs, ALUs, so on and so forth. So I'm going to show. See, Ian, I appreciate that. You and Sal are my favorites. I love your retort. Hey, you got to keep it fun. We got to keep it fun, keep it entertaining. So we love our atheist buddies. Lena Powell has Lena, you've been such a blessing. And Lena versus Ian. Poor Ian wouldn't stand a chance. Ian's proud of his trash talking for form. Hey, we got thick skin, and our atheist buddies got thick skin too. And let's screen share here. I want you guys to see. So I'm going to go on mute again. Make sure there's no background noise. But I just want to point out though that, for example, a prediction on, say, the Khoisan peoples. Hey, I'm so confident with the mutation rate, I'm going to predict that these people groups who we don't know their mutation rate yet, I predict they're going to mutate this much. Okay, their DNA is going to change this much in however many generations. Now, we actually have to test it, get their DNA. We'll see if it's true or false. That's called a future testable prediction. Now, there's been predictions on the history of civilization, which some on the Y chromosome have come true, and they're coming true more and more every day. So also prediction after prediction on mutation rates in animals as well as speciation rates. So anyways, here we go, guys.
And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.
Well, because I've even got another paper here, and I can post them in the chat after. It says ERVs frequently act to distribute regulatory information and thus confer genes with new patterns of expression and function. And I mean, I can go on and on, but for sake of time, I'm not going to. These, even if we just look at the greater class of retrotransposons, the fact that they're extremely good for us, they can, that's why some of them are called jumping genes. They can jump around in the genome, and they can turn on and off various types of genes. And there we go, paper after paper. Oh no, it's just one or two, functions that were easily co-opted, even though we have no evidence for the co-option. No, the evidence suggests that these are all created units of DNA function. And just some of these comments with our good friend Speed, we love you. We hope you're doing well. But look at this. Just give me one prediction. I mean, you want a prediction in geology with the cold slabs. You want predictions in astronomy with Dr. Russell Humphreys. You want the huge number of predictions coming from Walt Brown's model. We just had Bob Enyart and Brian Nickel on where they talked about it for 2 hours. You want the number of massive predictions coming in genetics from Dr. Jensen, Carter, Sanford. Let's see, here's one thing. One paper there on the Y chromosome. The history of civilization. One paper was just shown on screen. Okay. Let's see, because I've explained it 1,000 times. Let's see if any atheists in the chat, okay, can reiterate Dr. Jensen's history of civilization predictions on the Y chromosome and the mitochondrial DNA. Let's see if they can. Sure. So Speed says, just give me one. Just give me one. So that's the one I'm talking about right now on a history of civilization prediction on the Y chromosome mitochondrial DNA. He just came out with a paper in December on the Y chromosome, detecting signatures. Okay. Here's the thing. If these phylogenetic trees, if what we see in the Y chromosome and the mitochondrial DNA really is a reflection of hundreds of thousands of years in deep time and not roughly 6,000 years, then what we would see for the most part is a lot of genetic noise. Okay, you wouldn't be able to differentiate between noise and signatures. But guess what? Jensen made this prediction. He just came out with a beautiful paper in December showing just that. He is reading from the Y chromosome, from the mitochondrial DNA. He is showing demonstrably that this is a reflection of just thousands of years. Anyways, I can't let this get derailed for too long, answering the same questions 1,000 times. So the next clip I want to show you guys is Dr. Sarfati reiterating and adding a couple new points, solid points to what I was saying earlier on viruses, bacteria, and the benefits of them. See, and Speed of Sound, he doesn't want to admit that what we're seeing is genome-wide, at least 60, 70% activity in our genetics, as well as these variation-inducing genetic elements, which were never predicted to have the incredible functions that we find them having today. But yet this was all predicted by intelligent design advocates, those that believe in a creator, and those that don't assume junk. If you looked on under the hood of a car, are you going to assume this is all junk just because you don't understand it? Have a kid look under the hood of the car and say, hey, start tearing out things that you don't understand what they're there for. He'll start tearing out everything. No, we understand so little of the DNA language. So creationists have predicted a lot of DNA function. Dr. Jensen has looked at specific DNA positions. He's got specific predictions in print where, hey, this specific DNA position is going to have this function. Or if you mutate, you mutate this specific DNA position, it's going to result in disease. And sometimes the specific disease can be named. Prediction after prediction on function, so-called non-coding DNA versus coding DNA. So God bless you too, Lena. God bless you too. And awesome. I'm glad Ian says he likes the new shirt. I appreciate it, my man. I appreciate it. So lots of good people in the chat. Doki Doki, thanks for the super stickers. You guys are great. So I want to show this clip real quick, and then we're going to go over a paper as well. And okay, here we go. Him say, good to see you as well. Says genetic entropy is a good, yeah. Here's the thing, genetic entropy. They got no explanation for these nearly neutral mutations that accumulate from generation to generation, just slightly deleterious. Selection can't see them. That's the whole point behind neutral theory of evolution. They build up like a hidden reservoir for evolutionary advancement where they can be called upon later for change, adaptive purposes, for example. But no, it turns out they're slightly deleterious. They're effectively neutral, and they slowly degrade us. This has all been confirmed through thousands and thousands of numerical simulations. Can't be refuted.
Evidence against young Earth creation. What's the
okay? Most bacteria and viruses are good for us. I mean, you've got probably slightly more bacterial cells than human cells in a healthy human body.
Right.
Well, I think it's about 30 trillion human cells and about 38 trillion bacterial cells. Most of them are in your large intestine, the colon. Okay, so they're good for you. As soon as a baby's born, the large intestine is populated with trillions of these bacteria. The immune system is working really, really hard, much harder than it works when your baby's vaccinated. So the hardest thing it has is to try to control these germs inside your gut so they stay where they're meant to be. But they're doing a good thing. They're actually helping you digest some food, you see. So they're good for you. And most bacteria are good for you even now. But there are ways since the fall happened that some good things could become bad things. I mean, it seems that some of the parasitic bacteria are related to bacteria which are not parasitic, but the bacteria have lost about 80% of their genes.
Wow.
Which means they have to be parasites. They can't get the nutrients unless they're parasites. But the thing is, they've lost a lot of information. In fact, you look at parasites, they seem to have all been degraded. They're genetically deteriorated in relation to some beneficial germ. There's some machinery that gets lost sometimes, and the thing has no choice but to be a parasite. And even viruses, you've probably got 10 times more viruses than you have bacteria in your body, because the viruses are helping to regulate the bacterial population in your intestines. So they're doing a good thing as well. These are bacteriophage viruses that are regulating your bacterial population, and they're all over the earth. I mean, in the sea, you've got bacteria, viruses regulating all these things. In fact, one secular article earlier this year was saying that, yeah, if we eliminate all viruses, you'd probably be healthy for about 1.5 days before you started to die. And I think even coronavirus, I mean, that seems to be a benign bat virus that's got out of its proper habitat.
Right.
Influenza seems to be a benign avian, is it waterfowl, ducks and things like that. It seems to be a benign thing. It does some good in the duck, but when it gets out of the duck population, comes into human, it can be very nasty.
So when these viruses jump species, or as you said, jump from their original habitat, that's where they can become harmful. That's when they can burn hot and fast, kind of thing.
Yeah, that's a big thing, yeah. And Dr. Carter's written articles about that. He wrote on the coronavirus, and that's the thing called zoonotic viruses that originally were in other organisms. It seems that bats use viruses to keep down cancer. It seems like they kill cancer cells quite well. So they do some good for the bat, but when they get out of the bat, they do some harm for us. Ebola and the coronavirus, the COVID-19, SARS-CoV-2, does harm to us. And Ebola does harm to us, but it probably does some good things for the bats.
Right. That's a really, really good point. To us, I'd imagine our immune system, it's foreign to us. Therefore, we can't, our body doesn't recognize it. I love the answer you're giving, because this is an argument that they sometimes pose to us as like a knockout argument, when in fact it makes me, based on what you're saying, Dr. Sarfati, it makes me wonder, imagine being in a world without bacteria and viruses. Like you said, we'd survive even a day.
And I think therefore Adam pre-fall would have had an immune system, because the immune system distinguishes between self and non-self. So if Adam had healthy bacteria in his large intestine, he still had to have the immune system to keep the bacteria where they belong. So even in the pre-fall world, there would have been a function for the immune system. Right. They wouldn't have got sick because it would have worked perfectly. Now our immune system doesn't always work perfectly because we're living in a form where Adam and Eve's immune system would have been perfect.
Awesome answer. Well, okay, guys, so I want to share an article here that's going to talk a little bit more about this, and we're going to go through it. Okay, so let's check it out here. There we go. Okay, so this is what we've been talking about. Anybody who just got here, we spent the first good portion on mitochondrial DNA phylogeny, as well as Y chromosome, debunking the critics and their arguments against independent origins. We've then gone on to this topic of viruses, viral-like elements, endogenous retroviruses, and then we're going to end it with some genetic entropy as well. Okay, so let's see. Some evolutionists allege that 8% of the human genome originated from viruses. This number is ambiguous, since different authors include different genetic elements as viruses, such as signs and lines. For example, ALU elements make up at least 11% of the human genome. Now remember, the evidence seems to suggest, guys, based on everything we've discussed, the huge numbers of papers that we've gone over, these are, and let me know how my audio is too, guys, these are variation-inducing genetic elements, okay? That's what they've originated from within. They've been created. You can have rogue agents, external escapees, internal escapees, okay? Genetic entropy can mutate a bacteria to the point where it's lost so much of its genes that it's now become bad. It's become a parasite, essentially. This is what the evidence suggests. And these arguments from this guy, Barry, his blog, he keeps commenting on my Facebook page, and I say, let's debate live. This is why he won't, though, because then you can call him out for providing evidence that doesn't help differentiate between the models as to whether or not these are created units of DNA function, whether or not they've originated from within or from outside. Okay, no. We need to explain that which can differentiate the explanations and models. If I were to come to a debate and say, hey, Luca, the sky's blue, creation is true, you'd say, so what? Evolution can also explain why the sky is blue. Or I were to say, hey, speed of sound, the earth is a sphere. You're not related to a banana plant. You're made in the image of God because the earth is a sphere. Speed of sound would say, so what? I can also explain from my model and my starting point, why the earth is a sphere, why the sky is blue. We need to focus on that which can differentiate the two models. And all the arguments that we see for endogenous retroviruses and retrotransposons, okay? All these arguments are not helping to advance the debate. Our major prediction, okay, is function, benefit to these variation-inducing genetic elements. And that's exactly what we see. It's exactly what we find. It's exactly what we've predicted. And dokie dokie, I got to say, coffee would be good right about now. Since time flies by, I said, we're just going to do this for an hour, and already we're going on an hour and a half. Okay, so let's keep going. According to another study, 22.4% of the genome is covered by endogenous retroviruses. Well, I read 3 sentences, guys, and I went on a 3-minute rant, so I'm going to try and avoid that, or we'll never get through this. So let's follow along. They claim that this came about when viruses infected humans and inserted their DNA into the human genome. This process is believed to have taken place over millions of years of evolutionary time. However, this has never been scientifically proven by direct observation. And remember, guys, this co-option of function, never observed. I have now officially had about 100 debates. Most of those, the ones I should say that I've asked, hey, show me observable evidence. Show me a technical paper of a non-functional ERV going from non-functional to functional. And guess what? It's never been presented. One biologist I debated, he at least had a bachelor's in biology, I think it was, on T-Jump's channel. He said, hey, listen, if I could present, if I said I had a paper that showed empirically in the lab in real time the co-option of an incredibly important function that we find these ERVs are having and exhibiting, I'd be lying because they don't exist. Dokie dokie, thank you so much for the super sticker. Thumbs up, I like it. Okay, so here we go. Researchers from the University of Massachusetts Medical School have been studying the spread of koala retrovirus as it infects the genomes of koalas from northern to southern Australia. Based on this, these researchers claim that a similar process could have also happened with other viruses in our own genome in the distant evolutionary past. How do retroviruses such as KORV manage to insert themselves in the genome of a species? A retrovirus is a special kind of virus that inserts its own genome into the DNA of a host organism. Hence the retro, right? That's why they call them a retrovirus. A well-known example of a retrovirus is HIV. But here, this is important, guys. Watch this. This infects our immune cells, okay? But usually retroviruses spread horizontally from individual to individual, sometimes causing illness as they go along. But this process does not allow them to insert themselves permanently as part of the genetic material of a given species. Also, guys, lead to incredible benefit and function in determining cell types and gene expression, in immune responses, in epigenetics. I mean, these evolutionists are grasping at straws. What researchers want to see is whether the virus can transmit itself vertically, right? There's a difference between horizontal transmission and vertical transmission. Okay, guys, I want you to pay close attention to that. From parent to offspring. This would mean that the virus has become a permanent part of the genome of the species and will persist in the species in the long run. During horizontal transfer, viruses spread between the body cells of 2 individuals. But during vertical transfer, viruses jump from a somatic cell, right, a regular body cell, to the germline. The germline is made up of reproductive cells, sperm and eggs. If viral DNA is incorporated into the genome of the cells that give rise to the sperm or egg cells, then the virus will survive to spread in following generations. And remember, guys, this is just the start of the problem for them. The next major problem is the actual co-option of these incredible functions that we've detected, that we've predicted, that we've expected if they've actually originated within the genome. And if they are created units of DNA function, then they want to ask you, well, why do we share so many retroviral elements with the chimpanzee? That's because we share a lot in terms of morphology, anatomy, physiology, and genetics with the chimpanzee. So if these are created units of DNA function used for function in the DNA that is then reflected by the phenotype, then of course we're going to share those similarities with other similar organisms. That's why we also have ones we don't share, because we're not exactly the same. But we're close enough that we're going to share a lot of these variation-inducing genetic elements. We'll share more with a chimpanzee than we do with a creature that's not quite similar to us in terms of the way the chimpanzee is. Okay, so let's keep going here. Those viruses, which have become totally fixed within the genome after a long time, are called endogenous retroviruses. That's where they get their name. According to evolutionary theory, in this manner, the genome would be much like a molecular fossil graveyard. In this graveyard, we would find the remains of different kinds of retroviruses as a sort of genetic fossil record of infections by retroviruses over millions of years. See, it's like when they look to the fossil record and they're looking to the transitionals, right? They're looking to fossils. Just like in the genome, the evolutionists want to look to the genome for fossils. To them, it's like a fossil record. Let's look at these genetic mistakes like the pseudogenes. That's why I always say the head-to-head prediction is DNA function. You know, if created heterozygosity is true, and God really did front load the genomes of living organisms with functional and helpful and beneficial diversity, including these variation-inducing genetic elements, then we would expect just that function, okay? So that is a direct prediction coming from the creationist model, while evolutionists believe this has all been a process of genetic mistakes, evolutionary leftovers, genomic fossils. So that's what we should find if evolution were true. And that's why it's funny that that which they point to as being the evolutionary leftovers, as being the genomic fossils, it turns out that no, they are functional DNA elements because they are beneficial to life. They are functional to life. They are crucial to life. Head-to-head prediction, and it's the creationist predictions that are being fulfilled more and more every single day. Why would the cell replicate a bunch of junk? A bunch of worthless junk. Not to mention the fact that these pseudogenes or your ALUs, your ERVs, if they really were just evolutionary leftovers, genomic fossils, a molecular fossil graveyard, they'd be mutated to oblivion. A lot of what we see is conserved, preserved. Okay. So let's see. Where were we? The older the retrovirus, the more copies it has in the host genome, since it infected the genome much longer ago, or so the story goes. This is how evolutionists try to explain the presence of 30 to 40 different families of viruses present in 1 to 1,000 copies each, allegedly introduced over the past 30 million years, according to the evolutionary timescale in the human genome. So this is going to be important, guys. Once inside the human genome, several things can happen to retroviruses. Usually they can lose their function and degenerate into functionless DNA. They can also cause illnesses such as cancer. This happens when the retrovirus disrupts a gene by inserting itself right in the middle of it. This would be like inserting a long paragraph in Russian into the middle of an English novel. The result would be unreadable. Evolutionists amazingly claim that retroviruses, Brother Brandon, good to see you, man. Good to see you. Always a pleasure. Yeah, they deny reality. They deny reality. Here's the thing, Brandon. The same people, okay, that say there's no evidence for genetic entropy, it's not real, it's not reality, because they're denying reality. In 1 week, I discussed genetic entropy live with Leophilus, David Neff, and Mr. Parker, who goes by Godless Galaxy. 3 critics that say in live streams when they're with their evolutionist buddies that there's no evidence for genetic entropy. Then you get them in live discussion, live debate, which is why this Barry guy only wants to be a text warrior instead of have a live discussion, because guess what? You get them in live discussion and suddenly they don't have any answers. They crack. And suddenly they have to go from being so condescending and overconfident to, well, I'm not a geneticist, and that's fine. But guess what? Population geneticists recognize there's a problem of mutation accumulation, which is why they're coming up with artificially contrived rescue mechanisms like mutation count mechanism, synergistic epistasis. Why are they coming up with mechanisms to explain something that doesn't exist? Answer me that one, Leophilus. That's too funny. Anyways, let's keep going. This would be like inserting a long paragraph in Russian into the middle of an English novel. The result would be unreadable. Evolutionists amazingly claim that retroviruses can also be, so here's this, can be reprogrammed, right? With no evidence at all. Evolutionists amazingly claim that retroviruses can be reprogrammed or repurposed to take part in cellular processes. One frequently cited example is the syncytin gene, which this Barry guy used as an argument in his review of my book, which allegedly originated from a retrovirus and which was recoded to take part in the fusion of certain cells to form part of the placenta. This is all retrofitted. It's all storytelling. It all assumes their story as compared to the important question as to whether or not these are created units of DNA function. Okay. Let's see here. I want to go down to, let's see here. Okay. Does viral invasion of host genomes make sense? So to read the whole thing, guys, I'll post this in the description, but it's kind of long. So for sake of time, I'll skip down to this part. The evolutionary picture of viruses invading the genomes of animal species and slowly integrating as functional units into their host genome over millions of years runs into numerous problems. First, the spread of KORV within koalas has been happening for only 100 years, not millions of years. This time frame better fits the biblical timeline rather than the evolutionary time scale. Remember, a lot of these that have gone bad, they have gone rogue, they are internal scapees, okay? Mutation can do this. Mutation can make a beneficial bacteria. It can turn it into something bad, something harmful, a parasite essentially. Second, if KORV is useful in the long run, then why does it cause such debilitating diseases such as cancer? The researchers studying the KORV have even suggested producing a vaccine against the retrovirus to save the koalas from extinction. How is it that so many inactive copies of KORV survive in the koala? Jungle jargon. Yeah, it's that they talk such a big game, scoff at Dr. John Sanford, right? But then when you get them into a live discussion and you point out the fact that, hey, listen, you can't invoke selection to remove that which is unselectable. So what type of mechanism is going to remove that which is unselectable but still slightly deleterious, okay, to the genome over time? And they've got no answer because there is no answer. Genetic entropy puts shelf lives on genomes. Let's keep going. Around 8% or more of the human genome is made of retroviruses. If the KORV is retained in the koala genome as junk DNA, it would most likely have been removed from the genome. Remember I was talking about this earlier? It's costly for the cell, guys, to replicate so much junk. The cell would rather get rid of it, or natural selection would get rid of it. If it's just a waste, it would cost the cell too much energy and material to keep the junk DNA intact for an indefinite length of time. This would be like printing a book with extra pages of gibberish at the end over and over and over again. Isn't that right, guys? It would be superfluous to keep junk DNA in the genome for such a long period of time as deep time evolutionists would say we've been around for. Yeah, just keep all this junk DNA, all this worthless, useless evolutionary leftovers in there. It'll be wasteful for cellular processes. without eliminating it. It is much more likely that ERVs such as KORV already had some function in the genome to begin with. Remember, if they've originated from within, they're created. You can get internal escapees, external escapees, good variation-inducing genetic element to bad variation-inducing genetic element for a number of reasons that we've touched on. Right? Here's the GAG gene, Pol gene, ENV, LTR, LTR. You know, Luca was talking about how can we identify these? Yeah, that's not the debate. That's not the debate. We agree on what they are, but we don't agree on what they're for. We don't agree on the origin of them. And these are the only arguments you're going to get from the evolutionist side. They're not going to make predictions. They've never made predictions on the function. Guess what? We'll put it on print. Hey, this DNA position is functional for this reason and this purpose. Hey, this specific type of creature, because of its function as being, say, a mammal, or its function in physiology, it's going to have this function versus this animal type, which we say is not related. It's going to have this type of function in a similar genetic sequence. We can make these types of predictions. We can say, hey, this genetic sequence or this DNA position, if you mutate that in a mutagenesis experiment, it's going to result in a disease because it's functional. It's there for benefit. It's there to be helpful to the organism. It was created. Okay, we can make those predictions, and we've got a ton. You got people like Speed of Sound who say, show me one, I'll show you 1,000. Okay, that they can't counter either. That's the structure here of this KORV genome, right? You got the GAG and Pol genes are responsible for inducing genetic variation. The ENV gene codes for the outer envelope of the KORV virus, but can be associated with genes in the host genome. This Barry guy with his blog, his ERV blog, and his comment about the Phoenix experiment, which I decimated, he won't be able to respond to this. He can come debate me on this if he wants to. The challenge is there. Also, it is a wide stretch of the imagination to say, this is what I was implying earlier, guys, that it's likely to disrupt the existing genes, okay, as compared to improve it or make it as functional and important to the genome as we know these elements are. Okay, because if you had a painting and you had a painter and you put a blindfold on him and you said, finish this painting, make it as best as you can be, okay, and he started just applying just random brush strokes, doesn't even know what he's doing, can't see anything, what's going to happen is he's going to ruin the painting. He's going to mess it up. It's not going to make it better. Okay. Lastly, why is it that host piRNA already exists in the genome with a sequence? This is important. With a sequence. Thank you, Doki Doki. I appreciate it. Hope you guys are enjoying this. Hey, 5:30 in the morning. We got 20 people here. This is awesome. That's why I love my audience and supporters. You guys are a bunch of night owls and party animals like myself. All right. Already exists in the genome with a sequence, which is complementary to that of the GAG and Pol genes. Interesting. It is as if the host genome had been able to look ahead and had already come up with the piRNA sequence in order to counteract and deactivate the GAG and Pol genes of the invading retrovirus. But evolution, right, this is where they want to give evolutionary mechanisms a mind, because they don't want to attribute what we see in our genomes to a forward thinker, I'm sorry. No, they need to apply evolutionary mechanisms. They need to apply a mind to them. But evolution is built upon blind chance and cannot know ahead of time what kind of challenges will face the organism. This is like stumbling upon a tribe of isolated forest dwellers, one of whom can speak perfect English with you. See if Speed can answer that one in the chat. It is more likely that piRNA already existed within the host genome as a design element to keep the levels of the KORV in check. All right, here, guys. Here's why creation is the better explanation for the 100th time. And we're going through technical papers from the secular side, technical papers and articles from the creation side. We're going through clips. We got a ton here showing that evolution fails on all levels, guys. It is possible to reinterpret retroviruses according to our model. Accordingly, so here we go, guys. This is what I was saying earlier. Accordingly, and I said the same thing to Team Skeptic in our debate. And his response was, well, there's no evidence for that. After providing all of this evidence that I've done tonight, showing that retroviruses could have originated from within the host genome instead of invading it from the outside. This had to, guys, listen. This had to have been the case in any scenario, since viruses are dependent upon host cells. Remember that. This had to have been the case in any scenario, since viruses are dependent upon host cells. Any evolutionists in the chat, give us any reason to believe that they have come from the outside, when in fact, viruses are dependent upon host cells. This means that the cell's genome, guys, I can't emphasize this part enough. This means that the cell's genome had to predate viruses. Had to. God created the first people, the first organisms, and front-loaded them with these variation-inducing genetic elements. After the fall, many have gone rogue, many have gone bad, many have escaped internally, externally, but no, they've all originated for good. And that's what we see. That's what the evidence suggests. So now the similarities and the hierarchies that they form make sense according to our model, since of course we're going to share a lot of these variation-inducing genetic elements with the chimpanzees and other organisms that we share a lot with in terms of anatomy, morphology, physiology. This is just common sense. It's what's predicted. Viruses are incapable of surviving without a host cell. That is, the ERVs are more likely rogue products. Remember this. The ERVs are likely rogue products of the genomes of their hosts. And the parts of the genomes that look like ERVs are then seen as designed to do what they do, and they do it well, guys. Research will increasingly reveal functions. Isn't this funny? Here's a prediction right here that we are okay and confident enough to put on paper. Research will increasingly reveal the functions of these misnamed retrovirus elements. Dr. Ian Macready, at the time researching the retrovirus HIV, suggested this way back in 1999. Since viruses take up such a large portion of the genome, they must have some sort of function. Viruses are capable of transporting genes besides their own between bacteria, for example. Isn't this amazing? According to the variation-inducing genetic element, or VIGE hypothesis, coming from our model, certain genes in host genomes do not originate from retroviruses from outside. Rather, these genes are influenced by transposable genetic elements, which can alter the regulation of genes. When these transposable elements leave copies of themselves behind, they ensure that the new variation they brought about can be inherited. The transposable elements which cause the variation within the host genome are the gag and pull genes. The gene that they regulate is the ENV protein. The syncytin gene is attached to the ENV gene of the so-called ERVW element, which is expressed in a part of the placenta called the syncytiotrophoblasts. Say that 10 times fast. Yet another regulatory transposable element called the trophoblast-specific enhancer is responsible for expressing the syncytin gene only in the placenta and nowhere else. Syncytin is essential for successful pregnancy. So how did mammals reproduce before the putative ERVW infected the mammal line and then fortuitously develop this function. It is all rather fanciful, wishful thinking on behalf of the evolutionists. Isn't that funny? So, guys, I want you to finish reading this, but read the whole thing for yourselves. This is a fatal blow to the evolutionists who want to keep claiming that viruses, viral-like elements, retrotransposons, ALUs is evidence for evolutionary theory. No, this is not evidence for relationship between banana plants and whales. No. Speed, Luca, you're not related to a strawberry. I understand when you pick up a strawberry and you look at it and you say, look at all this similarity. You know, when I get angry or upset or embarrassed, sometimes I turn a little red like that strawberry, but that's not evidence that I'm related to the strawberry. Guys, you're made in the image of God, and that's what this evidence suggests. Variation-inducing genetic elements is what we are looking at. Okay? From within, certain mobile retrovirus particles originally could have moved from site to site within the genome, thereby changing the way genes are regulated within the host genome. It makes much more sense if retroviruses were originally designed as part of the host genome and escaped from the cell after the accumulation of mutations. All genetic entropy, genetic degeneration. Let's see here. Evolutionists claim that retroviruses such as the koala virus are invading. Luca, I do too. And they're good for you. Invading the genome of their host species. They say that this way, these viruses can help the evolution of the host genome by inserting novel DNA into it. This idea is rather implausible. It goes against the logic of natural selection because the koalas become sick due to viral infection. Therefore, these koalas infected with the virus would be eliminated together with any copies of the viruses within them. But there is a second hurdle at the cellular level. The koala virus must jump before it can fully get integrated into the genome of its host. This is a molecular selection system which eliminates genes which the cell does not recognize as its own. This involves special RNA molecules which bind to the virus genes, therefore removing them from cellular traffic and making it impossible for them to become a permanent part of the host genome. All right. That was a long one, guys, but an important one. We like to leave no stone unturned. So let's see how the chat's going. Got a lively chat. Looks like we got some creationists versus evolutionists debate in the side chat. Okay. Lots of fun. Baptist chat. Could you explain here just a second? I'm going to stop the screen share. All righty. See what we got here. So what we'll do, because we're going on 2 hours, is I could go on for another 10 hours on ERVs. But that's enough evidence for now, I think, especially to give the fatal blow to this blog by this Barry fella. Let me try and find Chad's question here. And I think I lost it. Well, he was asking how can we know that people lived longer in the past? Oh, here we go. Could you explain to us why people used to live to 900 years? Good question. So a lot of it is environment. A lot of it is genetics. Genetics and environment are directly related. You know, genetics plus environment oftentimes equals phenotype. So the pre-flood world would have been a lot more superior. Okay. Men and women, they would have lived a lot longer. They would have had less mutation accumulation as well. Mutations are destructive. They're the destroyer, not the creator. What we know about genetic degeneration, the fact that we accumulate roughly 100 new mutations per person per generation. If we take this point in time of most mutation accumulation, okay, we are consistently more and more mutant. Speed in the chat, he's got 100 new mutations. 100 more mutations that his parents didn't have. We are consistently getting more mutant. So if we take this back to a point in time of least genetic entropy, least mutation accumulation, that would be a point of perfection, a point of Adam and Eve, or say a point at the flood of Noah and his family. This would have been a point of increased lifespans, increased longevity. Now we have evidence because we have legends after legends and stories of what's called the golden age, right? Where men were living to 1,000, living to 500, 600. Oftentimes, yes, legends can be embellished, but they often are derived from a common source, a time where people were actually living to these lengthy ages. Now, here's the thing. I can go over a number of genes, and Raw Matt and I have done so. Raw Matt has had a debate on that exact topic where he absolutely demolished his opponent and met his burden of proof in that debate. Easy win for Matt. He's a genius at this topic. So what I'll do is I'll post that debate, because Matt goes over a number of, there's a certain antioxidant, okay, in lobsters. There's certain creatures like lobsters that apparently can live to 1,000 years old, and we're lacking in the same amounts of that antioxidant in our bodies. Also, there are numerous longevity genes that are broken and damaged. If you were to turn those back on in a time where we had less mutation accumulation, a time with better environmental conditions, guess what? If you have those longevity genes that are promoting longevity, well, you're going to live longer. Okay. So sometimes all you got to do, a lot of people, and I think the transhumanism field, health and longevity, they'll do what they can, keep their body as alkaline as possible to turn on some of those longevity genes that have been lost or broken or damaged or turn off. So, sun radiation, stronger magnetic field. So environment, big environment and genetics. You know, there would have been a lot less radiation damaging our skin cells. We have a lot of redundancy in the genome where we're constantly being bombarded by the sun's rays, external cancer-causing agents, for example, that our body's constantly fighting. So, okay, so let's see here. All right, I want to go to the genetic entropy part now, because I want to point out the fact that evolutionists don't seem to get the fact that selection acts on phenotype and not genotype, and they try and get around this fact. Leophilus attempted to do it, okay? And yeah, Lena Powell says, so there's somatic mutations, okay, in our somatic cell lines, like our skin cells, okay? There's 3 new mutations every cell division, okay? We accumulate massive numbers of mutations in our somatic cell lines throughout our lifetime. We are highly mutant by the time we die, but it's the germ cell line mutations that are actually passed on. Okay, so not the somatic. Here's the thing. Thank God for these DNA repair mechanisms, because of how many mutations we actually accumulate on a daily basis, okay, during cell divisions. Well, we'd be extinct in probably 1 generation, but our DNA repair mechanisms are constantly repairing broken DNA. This is also evidence of a forward thinker, okay? And when it comes to mutation accumulation, when it comes to genetic entropy, it's the fact that, and when I say we're becoming more and more mutant every single day, this is on a personal level. The fact that we're accumulating roughly 3 new mutations per cell per day, but most of them have just a very trivial effect on us. But eventually we die to mutation accumulation. But because, as Lena is correctly saying, some are passed on through the germ cell lines, okay? So every single generation, we've lost a little bit of information, okay? Now, we actually have a genome of 3 billion letters. We pass on 3 billion, okay? We get 3 billion from mom, 3 billion from dad. So those mutations, they're very small, very subtle, but they're unselectable. Selection can't see them. Mother Nature can't remove them. Change 1 letter in a genome of 3 billion, you're not going to have a huge effect, right? It's the accumulation of them over time. They're what's called effectively neutral. Too small of an effect on the organism to actually be seen and noticed by Mother Nature. Selection can't do anything about them. They're virtually unselectable. Now, here's the thing. Genetic entropy assumes that selection will remove the worst deleterious mutations, the most harmful ones, of course. and even amplify a really good beneficial mutation, which are still roughly reductive, okay? Generally reductive. Here's the thing though. These mutations, you can have a mutation, just a single letter change that can lead to a disease. That person may not live to reproduce. They've essentially been selected out, okay? But the typical mutation, guys, the typical mutation, it's not detectable. It just has a small effect like rust on a car, which Speed loves that analogy so much. But here's the thing I want to point out. Selection acts on phenotype, not genotype. Selection is acting on the level of the organism, the whole individual. I pointed this out to David in our last debate. Guys, we have 100 trillion cells. And guess what? In every single cell, every single one of our cells contains 6 billion nucleotides. Those 6 billion letters are in every cell. So Mother Nature has a job. She has to decide if Luca's body, if Speed of Sound's body, if Brother Will's body is going to be selected or not. Selection is choosing between the whole genome at the organism level. So guess what? Either we're looking at reproduction or non-reproduction, because all selection means is differential reproduction. And there's no type of mechanism that can be provided that can remove these effectively neutral mutations, okay? And it's ridiculous because they're trying to play games. The critics are trying to play games on the fact that selection acts on phenotype in very weird ways. Here's the point. Genes are carried in organisms. Consequently, okay, since genes are carried in organisms, the organism is the target of selection. You can't see each single nucleotide, each generation, and say, we're going to remove that one, it's bad. We're going to keep that one, we'll remove that one. No, we're consistently more and more mutant. And if there's a rebuttal from Speed in the chat, I'd love to hear what his mechanism is for removing these slightly deleterious mutations. Okay, so let's see. And here's the thing. This redundancy in the genome, okay, the third position codon variation. Walker in one of his videos was saying, there are absolutely neutral mutations. Guess what? They now know that these third position codons, okay, there were a lot of the redundancy in the genome. They help slow and speed processes in the cell. So even redundancy, okay, even redundancy in the genome, if it's hit through a mutation, it can have a slightly deleterious effect. Look at the tires on your car. Your tires on your car can take a lot of damage. The treading, for example, but eventually they will wear down. Eventually they will. Okay, so guys, I want to end it here with, I'm going to make this analogy again, okay, guys? Because this whole selection acting on phenotype, not genotype, is incredibly important. And Dr. Dan's argument, okay, what he was saying is the fact that humans, so Dan's saying humans, because Speed of Sound probably couldn't formulate a coherent argument if his life depended on him. So I'm not going to count on him in the chat. I'm just kidding. I'm teasing. Speed's a good guy. So here, okay, this is what Dan says. He says humans exist at an equilibrium right now, okay, what's called a selection mutation balance. And I got to say, you atheists in the chat, you guys make it that much more fun. So you're always welcome. Any arguments, rebuttals, let me know. I like to engage the chat. So this is what they'll say. There's a selection mutation balance. This is what Dan said in his video that he flopped on so bad. Okay, but this won't work because, as I pointed out, each generation has more mutations than the generation before it. And this is why when you look to the bigger picture, okay, when you look at a bigger picture, well, here's the thing. Speed of Sound has a problem now because he doesn't want to look at humans because, yes, humans, we have kind of removed natural selection because we have now learned to take care of each other. We have medicine. We took that away. We degenerate even faster. But here's the thing. Here's the thing. There's been papers that have come out now that says almost all mammals have a similar mutation rate, which means all mammals, okay, are degenerating at a similar rate. The fact that many animals, including humans, are not extinct yet, it's because there has not been enough time that has passed. This puts shelf lives on genomes. Now here, I want to point out the fact, okay? Okay. Evolutionists like Speed in the chat can't really, Speed, I've showed the paper that shows mammals have similar mutation rates. Here's the problem with the evolutionists a lot of the times is they're not even really up to date. Like, for example, when I was debating Mr. Parker, he literally, we had to spend 10 minutes disputing the fact that we inherit 100 new mutations per person per generation. So then I went, found the paper, presented it to him from Michael Lynch himself, who said, yes, 100 new mutations per person per generation. So Speed, I'll get you that paper later. Okay. So here's the thing. When it comes to humans, okay, nobody's going to say that humans are getting better genetically. Okay. Now they're going to assume that we are the worst because we have essentially removed natural selection. We live in a variety of environments, and I'll grab Speed of Sound's paper here real quick because he seems legit and I want to help him. So let's go right here. Boom, boom, boom. So as I'm finding the paper, pulling it up, I want to point out the fact that, okay, here, I think I'm close to it. I don't want to lose my train of thought. I'm going to put it into the chat in 2 minutes. So here's the thing Dan's missing, okay? When we remove, let's take all 8 billion people on the planet, okay? I'm gonna give Speed of Sound in the chat. I'm going to make this easy for him, okay? I'm going to say, okay, we've got 8 billion people on the planet. We're all multiply mutant. We've all accumulated thousands and thousands of mutations. Everybody in this chat, we've all got roughly the same amount of mutations, okay? We've all got more than our parents. And if we reproduce and have kids, they're going to have more than us. It's just basic. So, Speed of Sound. Here you go. Here you go. You can remove 50% of the worst mutants on the planet. Those that are just slightly more mutant than the rest of us. Okay? Remove them all. Now you're left with 4 billion people. 4 billion people. Did this help? Well, let's see. No, because the 4 billion people, the 50% we have left, because you've wiped out 4 billion, the worst. I'll let you have, it's not realistic, but you can have it. You're still left with 4 billion people, okay, who are still more mutant and have accumulated more mutations than the generations before it. Okay, so you can look to what Dan looks to. Go watch his video, guys. It's an embarrassment. Dan looks to fitness variation, equilibrium of beneficial mutations and negative mutations. They all fail to solve the mutation accumulation problem. Mutation count mechanism fails. It's been falsified through many, many, many numerical simulations that have been published. Now, here's the thing. Including fitness variation, including equilibrium of beneficial mutations and negative mutations, including purifying selection. It does slow down the degeneration process, but it does not solve it. It doesn't solve it. Even if, Dan, there is relative fitness between different individuals within the population, okay? Some individuals being better than others, it doesn't matter. It doesn't matter. It still comes down to the same problem and the same result. And I need to point out the numbers have been done. Thousands of simulations have confirmed genetic degeneration. Okay. These are never addressed. Yes, there can be selectable variation within relative fitness. These are all acknowledged. Just saying words doesn't solve the problem. But most people who watch, say, Dan's video, they're blinded and they're hoping for just any response. Any response is going to be good enough for them because they're not even understanding, for the most part, what Dan is saying. They can't see fully. They're just waving it away. because populations still only get worse naturally and continuously. Remove the worst. Speed, remove the worst. You're still left with populations of people worse off than the previous generation. Isn't that hilarious? How you can even give it to them. Give them a massive amount of purifying selection, and it still doesn't save the day. Okay, so here we go. Right here. A paper. So this paper shows that mutation rates are similar for all mammals when based on mutation rate per year, not per generation, though. Here, look this one up here. It was hard looking that up for you, Speed, while trying to make my point there, but I did it for you. Here we go. Thank you so much, Doki Doki. I appreciate it. Okay, so here's the thing. You can see they got nothing. They got nothing. Okay, they're dead in the water. I want to screen share a really good paper by Paul Price. Okay, Paul Price is the man. And his debate with Dr. Ron Garrett is to this day one of my favorite debates. And I'm going to be ending it with his opening statement that I thought he did an amazing job pointing out quotes from, yeah, just toss that into Google. You'll see it there. You'll see it there, Speed. Okay, so let's see. Mutations good. Where's the part that I want to see? Mutations happen in all life forms and in viruses. In our corrupted, fallen world, the mechanisms that replicate the genetic material from one generation or one cell division to the next are imperfect. Another source of mutation is environmental radiation. Each time we have children, we inevitably pass along some mistakes that were not there before. Now, here's the thing, guys. Even when populations go extinct, okay, like with humans, if we were to just wipe out 4 billion, you're still left with people that are more mutant continuously. You can't solve it. And the fact that the evolutionist science deniers want to fight reality so bad really speaks to the Bible's words when it says that they're willingly ignorant or they're sent a strong delusion. Another source of mutation is environmental radiation. So that helps with Brother Will, his question too, because environment has a huge effect. And in the post-flood world, that would have really, really helped with the decline in age. Each time we have children, we inevitably pass along some mistakes that were not there before. Estimates vary, but a common figure is that each child is born with about 100 new mutations. These are added to the ones already accumulated in previous generations. These mistakes are almost never helpful. You expect to improve an encyclopedia by adding more and more spelling mistakes every time one is printed. The evolutionary literature acknowledges this very clearly. Even the simplest of living organisms are highly complex. Mutations, indiscriminate alterations of such complexity are much more likely to be harmful than beneficial. In summary, the vast majority of mutations are deleterious. This is one of the most well-established principles of evolutionary genetics, and yet you still got evolutionists in the chat that are denying the fact that most mutations are deleterious, supported by both molecular and quantitative genetic data. One estimate is that damaging mutations outnumber helpful ones by 1 in a million, and even that one helpful one you get when you examine it, okay? When you look at the genotype, guess what? It's reductive. So it's still not taking things forward. Even most of the beneficial mutations turn out to break things rather than make things. It's much easier to break things down than build them up. Neutral mutations. Some people, especially those with scientific backgrounds, believe that most mutations are neither good nor bad. They believe the vast majority of mutations are neutral. This is a major misconception. Given how important the information coded in DNA is for living things, it is easy to see that most random changes are going to have some effect, and most of these will be bad. They will not simply do nothing from a scientific paper on the topic. it seems unlikely that any mutation is truly neutral in the sense that it has no effect on fitness, right? It's going to have some effect on genotype. All mutations must have some effect, even if that effect is vanishingly small. Thanks so much, Doki. I appreciate it. The heart of the hour. I appreciate the kind words. I appreciate it. It's all for the glory of God, guys. So if there's any, I always say, if there's any recommendations or there's any videos you want to see debunked or anything like that, let me know. But yeah, we're going to have a lot of articles coming out, a couple new books too for the new year, and a lot of solid interviews and discussions for you guys. So the party's just getting started. We are not going anywhere anytime soon. Sorry, Team Dodgeball. While there are essentially no mutations that are strictly neutral, mutations can be so minor in their effects that they're effectively neutral. Geneticist Motu Kimura created a new model where effectively neutral mutations were a huge proportion of the total. Anytime people say that genetic degeneration, guys, is not recognized, just know they don't know what they're talking about, and they're almost not even worth debating. He discovered that these mutations cause a general decline in fitness over time. This term fitness is often used in confusing and circular ways, though. Despite this, Kimura never questioned the notion of evolution. He took it on faith that occasional mega beneficial mutations would cancel out the effect of this gradual decline. Guys, the critics, like Jackson Weed in his video, they don't even look to see that Kimura just said these things in hopes that, yes, mega beneficial mutations would counterbalance the damage due to low impact deleterious mutations. But guess what? No, because the beneficial mutations, when they do happen, they're too rare. And secondly, they're still reductive. And thirdly, and most importantly, simulations have been done where they looked at mega beneficial mutations that were truly supposed to be helpful to counterbalance the damage. And guess what? Genetic degeneration is still inevitable. Thousands of mutations have confirmed this. Evolutionists are dead in the water. They're done. They got nothing. Whether such a small rate of deterioration in fitness constitutes a threat to the survival and welfare of the species, not to the individual, is a moot point. But this will easily be taken care of by evolutionists say the darndest things and ask the darndest questions just by looking at Speed of Sound's latest question, guys. But here's the thing. Laughter is the best medicine, and they give me a good laugh on a daily basis. So here's a quote this is Kimura. This will be taken care of by adaptive gene substitutions that must occur from time to time. But there is no evidence to justify Kimura's wishful speculation, where it's all about imaginative speculation with these guys. The evidence shows the opposite. Given enough time, organisms will eventually succumb to the weight of the damaging mutations that accumulate gradually and go extinct. In fact, a paper presented by Sanford and others at a symposium on information at Cornell University demonstrated that lots of such high-impact beneficial mutations would actually hasten extinction. They strongly interfere with selection for or against all low-impact mutations, which makes the problem of genetic entropy worse. What about natural selection? So here's a big one. Evolutionists will sometimes try to rebut these ideas by saying things like, if a mutation is damaging, it will be weeded out by natural selection. See, here's the thing. We understand selection, guys, is going to remove the worst, most harmful deleterious mutations. We're not against that. See, here's the thing. When these evolutionists, when you get them into live debate or you argue with them over it, they have very unsophisticated, unintelligent, and oversimplified arguments, okay? Because they have a very simplistic view of reality because they want so badly there to not be a creator. This oversimplified view of selection is drilled into biology students relentlessly in classrooms all around the world. They're just repeating what they've heard and blindly believed, right, guys? And it is greatly misleading because for most mutations, it is totally wrong. Natural selection, a straightforward, real process. This is what I said earlier, guys. It essentially just means differential reproduction. Some members of a population will reproduce more than others. Therefore, the traits that are possessed by the ones reproducing the most are going to become the most common in the population over time. The power of natural selection has been carefully measured. So how, guys, does natural selection have limits? Can it actually solve the degeneration process? The answer is no. For selection to be able to see the mutation, it must be strong enough to select. Doki doki, thanks so much. Hope you guys are having a good night. Nice to see that even at, 6:15. It's been a good night though, guys. I hope that we're getting a lot done and everybody's having fun. So here's what's important, guys, okay? For selection to see the mutation, it must be strong enough to affect reproduction by killing the individual before it can reproduce or by causing sterility or a significant decline in fertility. Thus, natural selection cannot see. So here's the problem, guys. How do you remove what it cannot see? Montaz, we're almost done, brother. We're almost done. I know. I need to sleep too. Okay, so let's see. Here's the thing. I'm so OCD with this that when I've got my checklist of things I want to do, I can't finish the streams till we're done. But we're almost done, I promise. We're leaving no stone unturned for these evolutionists. Just another fatal blow to them. So natural selection cannot see a nearly neutral mutation because on its own, the negative effect of the individual mutation is very tiny, far too small to cause any appreciable difference in reproduction. As errors accumulate with each generation, eventually their collective effect is very damaging. It is easy to see that selection does not weed out most mutations. We all have hundreds of mutations our ancestors did not have. Remember, guys, we've got more mutations than our parents and more mutations than our grandparents. Yet most people have no trouble becoming parents and passing on their genes. This is why this whole Erica argument, where most of them, all they can do, you got to redefine fitness. No, they just don't understand that which is common sense, a difference between an absolute fitness and a reproductive fitness. Because guess what? Most people, no matter how mutant they are, we all have accumulated so many mutations. Guess what? We have no problem having kids for the most part. Okay, there's a lot of mutations that are harmful enough, but do not stop somebody from reproducing. Like, I don't know why this is so difficult to understand for the evolutionists, okay? A lot of genetic mistakes, both old and new ones, don't stop people from having more kids and passing on the good and the bad. Only the really, 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 really detrimental mutations are actually going to stop true reproduction. Natural selection only works on individuals. Forced to acknowledge that natural selection is blind to nearly neutral mutations, a common evolutionist response is, and this is your main one you're going to see from your Dans of the world, once the accumulating damage from the mutations becomes significant, natural selection will start to remove them. That's the argument, guys, but this fails to understand the problem. Natural selection can only weed out individual mutations as they happen. Once mutations have accumulated enough to be a real noticeable problem, they are then a problem in the entire population. This is common sense. This is empirical, guys. Not just in an individual here or there. I mean, that's ridiculous. The whole population cannot be selected away except by going extinct. Remember, there's limitations. You can't select away the whole population. You can't select away too many. Now you got a small population that are going to be highly inbred and accelerate genetic degeneration. In short, if the world were even several 100,000 years old, remember, this puts shelf lives on genomes. This whole argument that you'll see from people like Speed, where, well, we're not extinct yet, or point to a certain animal, they're not extinct yet. Yeah, that's because there hasn't been as much time as the evolutionists say This puts shelf lives on genomes and makes large-scale evolution impossible. Genetic entropy means that we would have long since become extinct. This demonstrates that it is a biblical creation model, not evolutionary theory, that matches up to genetic reality. And it highlights the dismal future that awaits humanity apart from the intervening work of our Creator God. Our hope is in Christ, verified by thousands of numerical simulations. I'm going to just say this for speed. You can invoke whatever you want. Lots of junk DNA, lots of purifying selection, mega beneficial mutations. You can say genomes just change, which is ridiculous to just say, to wave away the data. You can look to mutation count mechanisms. You can look to natural selection. You can look to anything you want. And guess what? It's all been analyzed. It's all been published. It's all been looked at. It's all been done. And nothing can stop the eventual genetic degeneration of species. That's it. It's been confirmed through numerical simulations. Evolution has got nothing left. All right, guys. So, because a lot of us want to sleep, I'm going to end it with a video that'll go by quick because I'll play it on 1.5 speed. But Paul Price from CMI did an amazing job against Dr. Ron Garrett. And when Paul Price asked Dr. Ron Garrett, what's the difference between a neutral mutation, essentially, and an effectively neutral mutation? And Ron said he didn't know. And we love Ron here. He's awesome. He's given us so many good debates. I think I'm going to reach out to him for another debate as well. We've just been so busy, I haven't been able to set up the second one with him. So he's awesome. He's given us so many good debates. But in the sense of the science and arguments that he was using, when he said he didn't know the difference, that is precisely the problem these evolutionists have, is they don't understand the difference between a mutation that absolutely has no effect on genotype, nothing, and an effectively neutral mutation that population geneticists speak of, where they have only a slightly deleterious effect. They're still damaging, but the damage is so small that selection can't see it, and so it builds up. And these types of mutations are subject to genetic drift. And populations degenerate over time, slowly but surely. Any actual arguments? Welcome them. I've seen some evolutionists in the chat tonight. No arguments when it came to independent origins and mitochondrial DNA Y chromosome. No arguments on viruses, bacteria, endogenous retroviruses, retrotransposons, ALUs, and no arguments with genetic entropy. Because guess what? They got no answers. They got no arguments. They're denying reality at this point. We love them. We love them. We just don't love their science. So we're going to end with Paul Price. Pay close attention. He does a great job. And he quotes from the secularists themselves, who acknowledge the real problem, and they're not quote mining. And once again, speed of sound fails. Everybody give speed of sound a round of applause. Nearly neutral mutations are not damaging. And that is where speed goes wrong, because he thinks the majority of mutations are just that, neutral. When in fact, we now know that for the most part, there's no truly neutral mutation, because all must have even a small effect on genotype, even a small effect on genotype. And that is the fact. That is the fact. Even these third position codons, they're now known to be functional in terms of slowing down or speeding up the cellular processes. And mutations in there, although there's a lot of redundancy, they'll just be so slightly damaging that every time you get a mutation like that, it's just more and more damaging, more and more. So guys, I want to, and here's the thing. Here's the thing. If you want to just give speed, if you want to just give that to speed, well, guess what? That's all been done too. Anything these evolutionists can throw at you to solve the problem, they've all been analyzed. They've all been published. But they don't want to look at these papers. They don't want to examine the numerical simulations. And guess what? They don't want to write up their own critique or do their own numerical simulation and say, hey, this mega beneficial mutation rescue device that I'm looking for, or this rescue device that says most mutations are neutral, I'm not actually going to go publish an analysis of this. No, but guess what? We've already done it all Thousands of numerical simulations have done this. Actually, you know what? I'm going to share a screen on Dr. Sanford and Robert Carter. This was their response to all these critics. They even mentioned Dan Cardinal by name here. Okay. So let's see. Yeah, we read through this during our last genetic entropy video. We read through a lot of it. But there's a certain part that I want to. If a mutation has any effect at all from Dr. Sanford, it is because it is affecting some aspect of the organism's biological information system. This is logically true whether a mutation is high impact, moderate impact, or nearly neutral. Random mutations in the genome are just like random letter changes in an instruction manual, or the random flipping of binary bits in computer code. In all these examples, we know for sure that random changes will always lead, but according to Speed, only in the information system that makes life life is there changes and mutations, right? Changes in the nucleotide sequence that are just absolutely neutral, just no effect at all, like they never happened. In all these examples, we know for sure that random changes will always lead to a net loss of information, and almost all changes will be deleterious. Waiting for a beneficial mutation or a nearly neutral beneficial mutation is like waiting to win a lottery. It should be obvious to any thinking person that near neutral mutations, like all random changes in code, large or small, will very consistently be harmful. And there is one here that I wanted to go to on, yeah, this is a must-read paper. But there's one here. Yeah, brother Brandon says, Dan has been destroyed by CMI, SFT, and RAMA. Yeah, Dan doesn't have anything else to offer, to be honest with you. Yeah, so all their best objections, they've been dealt with. They've been verified through thousands of numerical simulations. All rescue devices that they could throw, okay? Selection, near neutral mutations, beneficial mutations. There's also the huge problem of selection interference here. Okay. So, I mean, you can put any, you can even set the parameters at a lot of junk DNA and still see, you're still going to see that mutations accumulate and genomes degenerate. This is it. So, so here's Dr. Sanford. Again, they have not, see, and they don't think through their arguments carefully. This is why Dr. Sanford doesn't even take them seriously. There's been no peer-reviewed, published rebuttals. The mutation accumulation problem is most severe in small populations because selection becomes less effective. There are almost 8 billion people alive today, making us one of the largest mammalian populations. Any mammalian population with fewer individuals should be even more subject to genetic entropy than mankind. Clearly, population size is a significant factor in many past extinction events due to mutation accumulation. And mutational meltdown is certainly relevant to all currently endangered species. Most mammals have mutation rates similar to humans. Remember, I showed that, I gave that paper to Speed earlier. Most mammals have mutation rates similar to humans. It is true that we take care of the old and sick, which may have a limited effect on selection efficiency. Then again, we tend to kill off a lot of people as we fight with each other. So even there seems like there's a balance, guys. Speed of sound's argument fails. It should be obvious that genetic entropy is not limited to mankind. Obvious to people who don't deny science, of course. And here's their junk DNA rescue device. H1N1 paper. Anyways, guys, so we're going to end it here with Paul Price. Listen carefully, make some great points. I highly recommend the debate in full. And we're going to call it a day, guys. We've gone for almost 3 hours. And let me check my checklist. We touched on independent origins, debunking the critics, ERVs, ALUs, viruses, all the goodies, and genetic entropy. Left no stone unturned, guys. So we're going to end it with this. I've been talking for 3 hours straight, guys. So sit back, relax, enjoy. We've addressed all the arguments in the chat. And I hope this has been engaging for everybody. So here we go.
Talking about one simple thing, which is mutations. And that's going to be the main thing that we need to nail down in our debate today. What are mutations and what are they capable of, or what are they not capable of? I'm going to start out by quoting from a renowned mathematician by the name of Ian Malcolm. And he has been quoted as saying, "Ultraviolet radiation is good for life. It's powerful energy. It promotes mutation, change." So now, obviously, notwithstanding the fact that Dr. Malcolm is a fictional character, what he has said there is actually pretty representative of what we would expect from a Darwinian worldview, or from a Darwinian standpoint. What would we expect to see when we look at mutations? Mutations are change, and for evolution to work, change has to happen continuously in all life forms. Change must be good. It must have brought us from a single-celled organism all the way up to human beings, to very complex organisms. So what I'm going to show you today, and what science is showing, is that that idea that change is good for life, arbitrary, unplanned change, that is the exact opposite of reality. So the power in Dr. Sanford's argument, and the power in the book Genetic Entropy, really lies in the fact that he has not only looked at people who agree with him. His argument is based upon the peer-reviewed evolutionary scientific literature. And he bases his points on all these points that secular evolutionists, population geneticists, like Dr. Kimura, for example, are willing to admit. And all we have to do is to connect the dots to see where they lead. That's the one thing that the evolutionists are not willing to do themselves. If they did connect the dots, they would be forced to relinquish their faith in evolution, and what Dr. Sanford calls the primary axiom, the idea of evolution from a common ancestor. So before I get into making this case, though, I do want to make a brief comment on the idea of creationists quoting evolutionists. Because invariably what happens whenever a creationist like myself quotes from an evolutionist is that we are accused of quote mining, which just simply means quoting something out of context to misconstrue the author's intended meaning. And I will be honest, I have seen that happen before, probably not on purpose. Somebody got a little overzealous or whatever. But I confirm with you today that that is not the case with these citations that I have provided. These citations are in context, and that is what makes them so powerful. It's not that the scientists aren't willing to admit to the dots. It's just that they're not, or they're very rarely willing to connect the dots to show what the implication of this data really is. So I think that actually makes Dr. Sanford's case all that much more powerful, because the people that we are drawing from to make this case don't want us to be right. Now, I am going to simplify Dr. Sanford's case here down to a series of 3 basic premises, which, if we can verify, will lead us to the conclusion of genetic entropy, which is the gradual decline of all, or at least nearly all, forms of life over time as a result of accumulating mutations. Now, first off, we also need to be on the same page. What are mutations? Simply put, mutations are unguided, unplanned mistakes or errors that happen during the replication process, usually of DNA or RNA. Sometimes mutations can also be caused by outside factors like chemicals or ultraviolet radiation, like Dr. Malcolm said. No transcription process is perfect, but life does have built-in processes of error correction to try to weed out the mistakes before they get passed on to the next generation. But in this fallen world that we live in, even these error correction processes are not perfect. And each generation, some typos in the DNA or RNA, some mistakes do get passed on. So we know that our DNA is the blueprint for life. It contains at least a large amount of the total information content that builds our bodies. So we could actually compare this idea to making copies of the blueprints for some very complex machine, like a fighter jet, for example. But each time we make a copy, we make little tiny typos, little slight variations. And these aren't planned or anything. It's just little mistakes that happen. And however, unlike with a real fighter jet, evolutionists would have us believe that life has no engineer, has no designer. There was no plan behind it. And in fact, it is these little copying mistakes, these mutations, that are the ultimate origin of the fighter jet to begin with. So as you can see, that is a little bit of a strange idea from the outset. It brings us to our first premise. Premise 1, mutations are the source of the raw material needed to drive evolution. So Heilbronn and his co-authors write in citation number 1, mutations are the ultimate source of genetic variation that natural selection acts upon. Understanding the rate at which mutations arise and the distribution of fitness effects of spontaneous mutations is therefore of central importance to the study of evolutionary biology. So what he basically means by that is mutations are the only game in town for evolution when it comes to the question of novel genetic information. This is where evolutionists go to get the new raw building material for life. If we show that mutations cannot be that source, then the only other option we have on the table is intelligent design or creation. Now, from a purely conceptual standpoint, we can realize some basic things about mutations. For any finely tuned machine like a fighter jet, there are obviously many more ways. If you just go in and arbitrarily make changes to the plans, there are many more ways that you could cause harm to the blueprint than there are ways that you could make arbitrary changes to improve it. And so even if you did accidentally stumble upon an improvement, it's very unlikely to be a large improvement all at once. It's much more likely to be a tiny fine-tuning improvement here or there. So with that, it brings us to our second premise, premise 2. The vast majority of mutations are damaging, and conversely, almost no mutations are beneficial. Looking at citation number 2, quoting Garish and his co-authors, even the simplest of living organisms are highly complex. Mutations, indiscriminate alterations of such complexity, are much more likely to be harmful than beneficial. And skipping down to citation 4, I'll read from Kitely and Lynch. They write, in summary, the vast majority of mutations are deleterious. This is one of the most well-established principles of evolutionary genetics, supported by both molecular and quantitative genetic data. So, all right, so far, so good. Actually, a lot of evolutionists would be willing to grant these first 2 premises that we've made here. But what they would like to bring into the picture is the idea of natural selection. Now, natural selection is not really a force. It's just an observation about how nature works. There are certain organisms that have more offspring than others, reproduce more competitively or more effectively than others. And so, as a result, the genes that are carried by those organisms are going to filter through the population and eventually become dominant in the population over time. And so we could actually simply call it differential reproduction. That's what natural selection is. And Darwin, of course, had this idea that the idea of natural selection could be responsible for evolution from simple to complex over time, higher and higher in forms. Natural selection is supposed to be able to whittle down all of the negative changes that occur and amplify up all of the positive changes. What we're going to show, and what modern science has revealed, is that that too is a hopelessly naive concept. So here's the other thing we have to get clear. It's this word fitness. And I've written on this topic with Dr. Robert Carter, who is a colleague of Dr. Sanford. And unfortunately, just like with the word evolution itself, the word fitness is a slippery and tricky word. It can be used in different places to mean different things. And what I've found, reading through these genetics papers, reading through the literature, I have, and I believe Dr. Sanford has spoken on this too, there's kind of a subtle division of meaning, a nuance of meaning when it comes to fitness. So for clarity, I'm going to divide fitness into 2 separate ideas. The first of those 2 I'll call absolute fitness. Absolute fitness would refer to the biological function of the organism, irrespective of its ability to reproduce. Whereas reproductive fitness would refer to the competitiveness of the organism in reproduction in the population. And I think it's very obvious and in fact self-evident that there are a great many ways that you could change an organism in a way that would reduce or increase absolute fitness while having no impact at all on reproductive fitness. So those are really 2 separate ideas. For example, I'll give one example of that. Let's say that you alter my genes so that my maximum lifespan is reduced by 10%. So I live 10% fewer years. So that would be a reduction in my absolute fitness because I'm now less healthy, less robust, I have a shorter lifespan, but it's almost certainly not going to represent a reduction of my reproductive fitness. Very few people actually have children in the very, very latter part, the last 10% of their life. So reducing my lifespan by that amount would not affect my reproductive fitness at all, but it would be a reduction in my absolute fitness. Now, my opponent has written, if a mutation is invisible to natural selection, then by definition, it cannot be deleterious. A deleterious mutation, by definition, is one that reduces reproductive fitness. But I hold that that is actually an oversimplification of this idea of fitness. He's only looking at one side of the coin, reproductive fitness. But we have a bigger picture to look at. And Dr. Kimura, one of the founders of neutral theory, Dr. Tomoko Ota as well, these scientists have come up with these ideas that they call neutral theory, but they're actually prevalent now. They are the prevailing view in population genetics. And at its core, this idea of neutral theory is a repudiation of my opponent's oversimplified idea of fitness. So that actually brings us then to our final or 3rd premise. And that 3rd premise is there are no strictly neutral mutations, but there exists a class of mutations called effectively neutral, aka nearly neutral, whose effects are too subtle to be seen by the process of natural selection and are therefore free to accumulate in populations over time. I'm going to skip down to citation number 7, which is actually the seminal work in population genetics where Dr. Kimura laid out and actually gave us a chart of his model of mutations and their distribution of fitness effects. And what he says is, he says, note that even if the frequency of strictly neutral mutations is 0 in the present model, a large fraction of mutations can be effectively neutral. Now, what does he mean? What is this difference between strictly and effectively neutral? I submit that is the difference between absolute and reproductive fitness. He says, under the present model, effectively neutral, but in fact very slightly deleterious mutants or mutations accumulate continuously in every species. The rate of loss of fitness per generation may amount to 10 to the negative 7 per generation. Now, Dr. Sanford thinks that's an underestimation. But he writes, whether such a small rate of deterioration in fitness constitutes a threat to the survival and welfare of the species, not to the individual, is a moot point. Of course, he says it's a moot point because for him, evolution is taken for granted. But this will easily be taken care of, he says, by adaptive gene substitutions that must occur from time to time, say once every few hundred generations. Now, this is an important quote because you can see here, Dr. Kimura said that a mutation can be effectively neutral and yet cause a loss of fitness at the same time. If all we're looking at is reproductive fitness, that doesn't really make any sense. And I don't believe he does anything in this quote or in that paper at all to substantiate his claim that these mega beneficial mutations that occur so rarely that he didn't even model them would actually be capable of doing what he's claiming. So we can deal more with this as the debate goes on, but I argue that Kimura just throws that speculation out at the end as a sort of rescuing device, but he doesn't do anything to support that claim. And I do believe I'm out of time.
Awesome. Well, thank you so much for that opening there, Paul. Very clear, concise. So you can see there, guys, the difference between reproductive fitness and absolute fitness, or strictly neutral mutations and effectively neutral. These are very important differentiations and distinctions to make that the evolutionists fail to make. It's a very unsophisticated and overly simplistic view that the evolutionists have. Okay, so that's why all their arguments, essentially, that we've covered today in 3 hours have failed. And guys, thanks so much for sticking it out with me for 3 hours. We touched on a ton. I could probably break this up into 3 parts, with the independent origins in the beginning, the ERVs in the middle, and now genetic entropy at the end. So thanks for sticking it out with me, Baptist Chad, brother. Email, I'll shoot you an email. Doki, thanks for the links. I'm going to screen share one last thing, guys, for anybody who might have just got here. Check out our new articles over here, creationsclothing.com. Eventually, so this is our home webpage for now. Eventually, we'll probably get a secondary one, but go to our article section, guys, and check out the 2 articles I just published in the last 2 days. This one, Neanderthals and Independent Origins, guys, going into the Neanderthals and the phylogenetics in great detail, as well as patriarchal drive. So here it is, guys. Tons of good information in there for you. And the one I just published today on refuting the critics on Adam and Eve. So this one you'll really enjoy as well. You'll find a lot of the common arguments from the critics. Even goes into some replacing Darwin stuff, guys, with some good sources for you. So check that out, guys. Once again, thanks so much. Hope you guys had a good stream. I definitely had a blast. I didn't know 3 hours could fly by. Brother Montaz, you can finally get some sleep. I'm going to go get a few hours of sleep, and then I have a busy day. I want to say tomorrow, but no, it's pretty much today as well. So the fun begins. Power nap is what it's going to be, guys. But I wanted to get this done for a few days now. And like I said, lots to look forward to leading up to Christmas and for the new year, guys. So God bless. Share around. Doki Doki, thank you so much for the last minute coffee. So God bless everybody who's just getting up. Enjoy your day, including you, Dan. Thanks for joining us. You have a good day as well. Have a coffee for me or a tea. Speed, you have a coffee for me as well. Maybe one of your morning reports. I like those morning reports. Lena, God bless. Always a pleasure. Luca. All right, guys. SFT is out, and we will talk tomorrow. Blessing.